Right, so today we are going to discuss the past paper questions of the last 4 years under calculus, that is limits and differentiation. Okay, so we did 2 sessions. In the first session we discussed the limits. In the second session we discussed the differentiation. So today we are going to take all the past paper questions related to that. Then only we are going to move on to the integration, maybe in the next session. Okay, right. So first I am going to take about 15 minutes to do a quick revision. Then we are going to straight away take the past paper questions. Okay, so right. So we subdivided calculus into 3 parts. The theory part, that is limits, then the applications, differentiation and integration. So what you see as something like this and what you see as something like this. Okay, so we have covered this, and we are going to take the past papers out of this. So let's quickly recap what is a limit and what is calculus, what is differentiation, what are the differentiation rules, what are the usages. Then we'll come back to go into the past papers. Okay, right. And also there are few background knowledge that you need. I am going to do a quick revision on those also. Okay, right. So we started with limits, right? So we discussed that calculus is all about limits, right? So there are situations where you can't determine in normal way. Okay, so just 1 minute. Okay, so there are situations we can't determine in normal mathematical sense. In that case we have to use the concept called limit. So the concept of calculus is based on the infinitesimal amount, or the very small amount, right? So very small amount, we represent it using delta x, simple or capital delta x. So it's all about infinitesimal amounts. So something like this or something like this. So then we can find out, of course, when the value is exactly that one, it may not be determined, but when we reach it to the point by making this 0 closer to the 0, we can find the limit value. Okay, so that is all about limit. So another name we given to the calculus is infinitesimal calculus. Okay, right. So we discussed a little bit of history. Isaac Newton and Leibniz parallelly they discovered or invented the concept of calculus. And yes, we discussed that there are 2 types of entities: continuous entities and discrete entities. Calculus is more onto the continuous entities, right? Of course there is a variation for discrete entities, but it's more relevant to the continuous entities. So if you cannot understand anything, but because now you have about one week since we did these 2 sessions, now you may have a lot of questions, right? Either you have fully understood, or you may feel like, okay, I have small gap here, small gap there. So this is the time to ask those questions, right, and clarify those things, right? So then you are done. So don't keep any questions with you, right? So then and there, anytime you can just ask those questions. Okay, so I am here to help you, right? So there are 2 types of things: continuous entities and discrete entities, right? So limits are more related to the continuous entities, right? Right? So then we discuss the concept of 0 and the concept of infinity. So 0 represent nothing. So we discuss some properties of 0, right? You can add something to 0 which is the same value. If you subtract 0 from something, it's the same value, right? If you do 0 minus something which is a finite value, it's minus of that value. If you multiply something by 0, 0. If you divide 0 by something, still it is 0. But we found some interesting things also. something divided by 0 is getting closer and closer to infinity. It's a limit to infinity. If you are reaching from positive side, it is positive infinity. If you are reaching from negative side, it is negative infinity. So now by this time you must have thought about these things, right? You must have thought about these things and understood, yes, that is what. So how do you understand these things? By taking some examples and looking at the patterns, right? So 10 divided by 10 is 1, right? 10 divided by 1 is 10, which is bigger. 10 divided by 0.1 is 100, it's getting bigger. Likewise, when this is getting smaller and smaller and getting reached 0, this is getting bigger and bigger. Of course, if it is a positive value, the value is a positive one. But if it is a negative value, it is a negative big value, right? For example, 10 divided by minus 10, it is minus 1. And 10 divided by minus 1, which is minus 10. And 10 divided by minus 0.1, it is minus 100. Now you can see it is getting bigger and bigger, right? And also it is negative, right? Because we are coming from negative side. So that is why x divided by 0 from negative side is, or limit x divided by 0 when we are reaching from negative side is, when I say negative side, this side, it is negative infinity. Then we discuss these two limits also. Something to the power 0 is 1. So again we took some examples, and of course 0 to the power something is 0. That is obvious thing, right? So that is not a limit actually, because when you multiply 0 by any number of times, so it will be 0. Actually these three are the limit. These three are the limits, special things that you have to understand. Okay. So other things are sort of a common sense. This is also common sense once you look at the pattern, right? Before looking at the pattern, for example, before looking at the pattern, you will feel like something to the power 0 is 0. That is your common sense or your gut feeling. But by looking at the pattern and analyzing, you will see that, okay, contradicting to my gut feeling, something to the power 0 is not 0, actually it is 1. So this is your gut feeling without knowing limits. This is the knowledge you get by looking at the pattern. Yes, it is not 0, it is 1. Right? So that is something that people have to appreciate. If the reality is this, we have to understand that is the reality. So science is all about understanding the reality, not something you believe, something you like. You understand what the reality is. So this is the reality, therefore we have to understand it as a concept. Okay, right? So that is all about science. Right, so we discussed that. So these three are very important. So those are the three limits that we learn at very first, right? So those are the three limits that we learn very first. Something divided by 0 is infinity. Something if it is from positive side, positive infinity. If it is from negative side, negative infinity. Something to the power 0 when it's, how did you write it as a limit notation? This one. Limit, right, n to the power x when x is reaching to 0, which is 1. So that is how you write it, right? So n to the power x when x is getting close and close to the 0, the result is 1. Of course here you don't have to write plus or minus, because in both sides it is 1, right? If it is both sides is the same value, we don't have to specify whether it's a plus or minus. But if they are reaching to different values, of course we have to specify which side you are coming from, right? So if you have any questions, please ask, right? So remember, maths is not to make you feel uncomfortable, right? Maths is not to make you stress out, no, right? So some people think like that, so they have a really bad attitude about maths, right? So maths is not about, not to make you uncomfortable, right? Maths is not to make you feel bad about it, stress, no. Maths is to give you confidence, right? Feel good about yourself, right? So then you will face your challenges, you will take up challenges, because you know that I have that potential, right? So I have that potential. Okay, right? So that is all about 0. So that is where we first start learning about limits, then we moved on to the concept of, this graph is really important, 1 over x graph, right? So using this, actually you understood these two. Something divided by 0 when it is getting closer and closer to 0 from this side, it is getting bigger and bigger. That is why we say this is plus infinity. when it is getting closer and closer to 0, from negative side it is getting bigger and bigger but negative. That is why we say this. So this 1 over x graph, just like you have remembered, right, things like y equal x, right, y equal mx plus c, right, y equal x squared. So just like you remember these things, right, or y equal x squared plus ax squared plus bx plus c, just so add to those tools, right. So those are some tools, you know, right. Please add to those tools these things, add that also, right. Now you can see, okay, I know the straight line, I know this parabolic shape, y equal x squared, y equal minus x squared. Now you have one more graph, that is y equal 1 over x, right. So that is very important, right. So those are the things that, so then when there's a real world problem, you think in terms of y equal mx, y equal x squared, y equal minus x squared, and now we have one more, y equal 1 over x, right. So you have to remember this. So understand this, appreciate this shape, because that is the basis to these two limits, right. So then you can understand this using arithmetic, or then using some numbers. You can understand or visualize this using the graph. Then all of a sudden your confidence is boost, right. Your confidence is boost. Now you are really comfortable with that, because you know that from number theory this is correct, from graph theory this is correct, right. So all of a sudden you will feel like you are in a real comfortable situation, okay, right. So when you are doing, so especially if you have attempted those past paper questions, so as I told you, so not only that you have to understand limits, so there are some background concepts, right. So I told you, right. So what are the background concepts? You must have good understanding about algebra, right. Good understanding about algebra. You must have a good understanding about trigonometry, right. Trigonometry. You must have good understanding about logarithms, logarithms and natural log, especially the e value. So now if you have understanding about these things only, you will find really comfortable about your calculus, right. So if you are weak in algebra, or if you have not done it properly, if you have not done your trigonometry properly, if you have not done your logarithms properly, right, so then of course you will feel like calculus is difficult. Actually not calculus is difficult, your foundation is not that good, right. So that is something you have to take that decision, right. So you have to make your foundation really sound, right. So that is why you had your relations and functions, right, in your semester 1, trigonometry in your semester 1, so relation and function in semester 2, trigonometry in semester 1, logarithms in semester 1. Of course these things you have learned in your O level also, right. So if you are shaky in these areas, of course don't blame calculus, you have to blame yourself. You have not done a good job in your other semesters, right. So therefore so it's very important, right. Okay, so so now add one more graph to your armory, that is 1 over x, okay, 1 over x, right. So that is the starting point of limits, right. Then we moved on to understand the concept of infinity. So infinity means endlessly very large. How large? Very very large. I can't even quantify, right. It's a concept, right. It's not a number. Of course 0, if you want, you can take it as a number also, but it's again a concept also. But infinity is not really a number, it's a concept, right. It's a concept, right. So then we discuss some properties of infinity also. If you add a finite value to infinity, still it is infinity, because it's not a number. If you multiply it by finite positive value, still it is infinity. But if you multiply it by a negative finite value, it's going to be negative infinity, or that infinity's sign is going to be changed, okay. Its sign is going to be changed. Then infinity plus infinity is still infinity. Infinity into infinity is infinity. Of course, if one of those has negative sign, the result is going to be negative infinity. If both are negative infinity, multiplying, you are going to get plus infinity, right. Then we discussed, so these things are not limits actually. These things are general common sense. That means which is sensible to your normal mathematical senses, so your gut feeling. But this is a limit again we discussed, that is so how do you write this? So this is informally how you are writing it, right? So 1 over 1 divided by infinity is 0, but really it is, this is a limit again, a limit when x is reach into plus infinity 1 over x, right? 1 over x equal, when we can write equal because we are talking about a limit, right? So otherwise actually this is reach into 0, but rather than reach into 0 we can say equal 0 because the reaching part is represented by limits, right? So of course when it is from plus infinity also 0, negative infinity also 0, therefore I can just say when x reach to infinity 1 over x equals 0, right? So that is if your number is getting bigger and bigger, right? So that is again common sense once you look at the pattern, right? So 1 over 1 is 1, right? So now we are making it bigger, right? So 1 over 2 is 0.5, 1 over 10 is 0.1. Now you can see this is getting smaller and smaller, right? So 1 over something like 1000 is 0.001. Now you can see it's getting big, small and closer to the 0. So therefore you can say that limit 1 over x, when x is reaching either from positive side or negative side, it's always getting closer and closer to 0. We are making it closer and closer to the plus infinity, or bigger and bigger plus positive side, or bigger and bigger negative side. Bigger and bigger negative side means 1 divided by minus 1, 1 divided by minus 2, then minus 0.5, 1 divided by minus 10, that is 0 minus 0.01. Likewise, still it is getting closer and closer to 0 because both sides we are getting closer to the 0 when we are reaching to plus infinity or negative infinity. Then we don't have to specify whether it's plus or minus infinity. The answer is 0, right? So again you can double check this again by using 1 over x graph, right? 1 over x graph, right? So again same graph you have to use. So that is why I said this is again very important graph. Now you can see when x is getting bigger and bigger plus side, it is reach into 0. Now you can see it's getting closer and closer to 0. So that is why we say when x over x divided by infinity is 0. Actually it is not mentioned here. X divided by infinity is 0. Again when x is reach into minus infinity, again it is 0, right? So by looking at this you are writing this, by looking at this you are writing this, by looking at this, right? So by looking at this side you are writing limit x tend to plus infinity 1 over x equals 0. By looking at this you are writing limit x tend to minus infinity 1 over x is still again 0, right? Now you can see 0 from negative side, here 0 from positive side, but anyway both are 0, therefore we can just say 0, right? Then we can say combine these two and say limit x tend to infinity 1 over x equals 0, because both from left hand and right hand side, if it is getting close to the same value, we can just forget about the sign and say that is the limit, okay, right? So you can see this graph is very important, another tool to your artillery or the whatever your toolbox, okay, 1 over x graph, right? So without understanding these things, so without understanding these graphs, don't try to understand calculus, right? That means you try to somehow memorize calculus or somehow pass your exam. So that's, you are, of course you may pass your exams, but you are not going to carry that confidence, right? So you are going to be a very unconfident or less confidence person who can't do things, right? So then you are going to end up in some boring job, right? Repetitive job, because you can't take challenges, right? So you don't want to accept the reality, right? So, right. So right. So that is how we discuss the concept of 0 and infinity. Then we discuss the concept of the indeterminate values. So remember, so these are the, so we have to remember this. So this is why we need calculus. We have these situations. What are those situations? 0 divided by 0, infinity divided by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, right? 1 to the power infinity, infinity to the power 0. All other situations like infinity plus infinity, right? Other situations like infinity plus infinity, right? Infinity into infinity, right? So no issue. 0 divided by something, no issue. But here we can't say what is the exact value. We can't say. It depends on the actual expression. Sometimes this situation might result in 1, sometimes 0, sometimes infinity, sometimes it will be plus 5, sometimes minus 3, sometimes 3 by 2, right? It depends on the actual situation. We can't say, but by just substituting you will get 0 divided by 0, but using limits you will find that of course actual value is something like this. It depends on the situation. So finding this actual value is called the calculus or the concept of limits, right? So when you plot the graph, we found that of course at this particular point it is reaching to this particular value, right? That particular value, not 0, 1, whatever the indeterminate value, it has a value. Yes, that value is 2 by 3. Yes, we got that value 2 by 3 using the concept of limits, right? So that is very important. So the idea is that you don't substitute the value, you reach the value, right, from left hand and right hand side and see what is the value. If it is reaching to a particular value, that is a limit value. That is the limit value. Okay, right. So you have to think, and if you have any question, right, if you have any slightest question, this is the time to ask, because now you had about 1 week time to think about those things, right? Now you had about 1 week time. So don't keep questions with you, right? Of course, if you are planning to resolve it within next few weeks, of course you keep it. Otherwise, please raise your questions, right? So I know that you have heard. I know that especially in Sri Lanka, you know that a lot of maths people, right? Maths teachers, they are like devils, right? So especially school level, O-level maths people, they always come with a lot of thuggery and etc. Why? They don't want students to ask questions. So to defend themselves, what they do is they become sort of a thuggery people, right? So why? They fear of people asking questions. So I'm not that kind of person. I always encourage you to ask questions. Of course, if I don't know anything, I will say, okay, I am also in doubt. Maybe I need little bit more time to think about that. Otherwise, I will explain it. Okay. So therefore, use this opportunity, right? So this is not your typical O-level maths teacher who is a sort of a devil person. I know, because I have experienced that. I have seen that kind of people in my school days, right? So always maths teachers are more than 70% of the time maths teachers are sort of a very I don't know, I don't like to comment on that, right? So therefore, so my task is not to scare you, my task is to make you more confident, right? So ask questions, right? Right, so that is very important, right? So then we discuss concept of limit, right? The concept of limit is we try to reach to a particular point, right, rather than substituting. Of course, if it reach to a particular point, we call that the limit. We call that a limit. Of course, you can reach to that point from left side or right side. If you are moving from left side, we say we are coming from the negative side to that value. If you are coming from the right side, we say we are coming from the positive side, because right side is all about positive numbers, left side is all about negative numbers, right? So sometimes these two limits will be the same, right? There are situations these two limits might be different, right? So that is possible, right? That is possible. For example, if you have a graph like this, if you have a graph like this, when you are coming from negative side, it might go to positive infinity. When you are reaching from positive side, it might goes to the negative infinity. So that means this is not same as this one. And there can be some graphs. It goes like this. It comes like this, and all of a sudden it goes like this. Then when you reach from negative side, it's maybe plus 3. When you are reaching from positive side, it may be plus 5. So that is possible. In that case, we say that we have a left hand limit, we have a right hand limit, right? Those are two values, but we have limits, right? But you don't have to say. So if it is fx, in this kind of a situation, we say that limit x tend to, say this is a, a negative side fx, yes, there is a value, there is a value. Limit x tend to a from positive side, there is a value, right? There is a value. So that is, this is the value, this is the value. But you can't say in this kind of a situation, you can't say limit x tend to a fx. No, there is no such value, right? But you have the minus and plus. Yes, there are two values, but those two values are different. In that case, we say that there is a left side limit, there is a right side limit, but there is no limit at a, right? Because they are reached into two different values. But if it is something like this, then your left value and right value is same. Therefore, we can say, okay, we have a limit at that particular point. Here we have only limits for the left and right side limits only in this kind of situation. But this kind of situation, we have the total limit also, which is same as your left and right limits, because we are reaching to the same value. Okay, right. So I hope you can understand. Of course, I am expecting you to raise questions if you don't understand. Otherwise, you are really timid, right? Feeble people, right? So you have hundreds of questions. You don't have guts to ask those questions. So that is the culture in Sri Lanka anyway. So that is why they keep believing all these stupid things, right? So they don't have guts to question those things, right? So same thing, right? So I hope you are not like that, right? So we did some examples. Then we discussed some theorems on limits, right? Limit x tend to a fx. If it is a constant, always the limit is going to be the same value, because if it is a constant function like this, right? If it is constant function like this, always the same value. For any a, the limit is going to be the same value of fc. That is common sense, right? Because it is not varying. The limit is always for any a value, and the limit is going to be that a value. Oh, that c value, right? C value. So that is common sense, right? So if you have any doubt about that, you have to ask. So there is nothing called stupid questions. What we have is stupid silence, right? So those stupid people are really silent, right? Of course, those who understand the things are also silent, but the real dumb people are also really silent, right? So therefore, those who are asking questions, of course, they are not stupid. Their process is working. They want to learn things, right? So they want perfect things. Okay. So I don't know which category you are belong to, whether you are a stupid silence people or really genius silent people. Genius also, they don't have questions obviously, right? But we have a category called stupid silent people, right? So they are stupid and they don't have enough guts to question that. Therefore, they are going to remain stupid. Okay. So ask questions and fix those things, right? So that means your process is working, right? Then if it has constant, you can take it out. If there is a summation, you can do the limits and do the summation of limits, subtraction of limits, multiplication of limit, division of limits. If there's a root, you can take the limits and take the root, right? So we did some examples for that, right? Something like that. So you can just apply the limit here, and then add those two limits, right? So of course, if there is constant, you can take it out, right? Things like that, right? So then we discuss the continuity also. So function is continuous at point A if its left limits and the right limits are the same. That means the limit exists, right? Limit exists. And if you assign a value to that fx at that A, that value also exists or defined, and those two are the same. In that case, we said that it is continuous at that point, because there can be so many situations where it is not continuous. For example, if you take something like this, right? So this is not continuous because the left limit does not exist, right? Limit does not exist because they are reaching to different things. And again, this is not continuous. Of course, I will do like this, right? If there's a hole here, right, hole here, then again limit does not exist because this is not exist, right? So likewise, there are situations limits does not exist. We discussed some possible discontinuous situations, right? So this is not continuous, right? Because the limits are different. The left side limit. So actually, the fx naught does not exist also here. Here again, fx naught does not exist. here the limit does not exist because it is plus infinity and negative infinity. Again, the limit does not exist, right? So this kind of situation we say they are not continuous, right? Continuous. So again another concept called continuity that you can think, right? You can see this is not continuous, here also not continuous, here also not continuous. But if you take something like this, yes, continuous. Somewhere like this, continuous. Somewhere like this, continuous. But here it is not continuous. It is not continuous, right? For different reasons, right? So then we discuss some limits related to infinity also, right? So if you have something like this, of course the extent to infinity exists that reach into L, right? Here also L, here also L. This is x reach to minus infinity because it's getting bigger and bigger in negative sense. Here it's getting bigger and bigger positive sense. So this is limit related to plus infinity. If a graph is something like this is a limit related to minus infinity. Of course it can limit from positive side like the lower bound sequence, or from negative side like upper bound sequence, right? So now we have to compare calculus with your sequence and series as well, convergence, because convergence and limits are really related things, okay? Really related things, right? Then we discuss some useful limits. So we just generalize 1 over x to 1 over xr, then x minus a, because then when x a is reaching to that, it becomes something like this, right? 1 over x tend to 0, right? Then we discuss there are 3 techniques you can use to evaluate limits. That is, of course, if it does not result in a indeterminate form like 0 divided by 0, infinite divided by infinity, or whatever, you just substitute. For example, if you are asked to find this limit, you can see that when x is 2, 2 plus 1 is 3, 2 minus 5 is minus 3, right? So 3 divided by minus 3 is minus 1. You can just find it. So that is okay, right? As long as it is not indeterminate form, then the limit becomes just substitute with the value, right? So here also it is okay, right? 0 plus 1 is 1 divided by 0. 1 divided by 0 is not an indeterminate form. 1 divided by 0 is 1. Sorry, 1 divided by 0 is infinite. Something divided by 0 is infinity, right? Something divided by 0 is infinity. Therefore answer is infinity. It's not an indeterminate form, right? So 1 divided by infinity is not an indeterminate form. 1 divided by 0 is also not in indeterminate form, because 1 divided by 0 is infinity. It has a limit, right? So likewise, so here it's something divided by infinity, which is 0, and of course if you draw the graph, you will find that it is reaching to 0 when x is getting bigger and bigger. If it is from negative side also, it is going to get 0. Of course this question is all about positive infinity, okay? So that is a technique 1. Technique 2 is, if you get something like 0 divided by 0 or infinite divided by infinity, or sometimes infinite minus infinity, see whether you have fraction, the common factors, right? Common factors, algebraic common factors. So that is a technique mathematicians found. If there are common factors, try to cancel out, right? Try to cancel out. Then apply the limit again. Then all of a sudden you will see it is not indeterminate form. That is a value, that is a real limit value, right? It's a technique mathematicians found, right? So here you can see, if you just substitute 1, it becomes 1 divided by 1, which is 0, 1 divided by 1, which is 0, 0 divided by 0. Now you are behind trouble. So now let's try to apply the second technique. Let's factorize and see, right? So we know that x squared minus 1 is x plus 1 into x minus 1. Then you can cancel it out. Of course you have to say that x is not equal to 1, because if it is x equal to 1, you are cancelling out 0 divided by 0. We are not interested about when x equal 1. We are interested about when x is reaching to 1. So that is why the question says limit, okay? Of course then all of a sudden 1 plus 1 is 2. So yes, that is the answer. That is the answer, right? So that's another technique. That is another technique we use, right? And of course if you can't find the factors grossly or obviously, another thing you can do is multiply it by the conjugate, right? Multiply it by the conjugate. So if a plus b is your value, a minus b is the conjugate. Sometimes when you multiply only, you will find the factorization. So in this kind, especially when it comes to something related to roots, we have to do that, right? We have to do that. Again you can see 0 by 0. But now what we do is we have to multiply it by, here you can't see the factors, right? But once you multiply by both denominator and numerator by that conjugate value, all of a sudden you are going to see the factors, right? So difference of squares, right? Now you can just cut it there, cancel out the common factors. All of a sudden now you can see it is something determinant. So that is another technique, right? So if you can just find it, of course, if you find it, you are fine. If you find some indeterminate form, and if you can find common factors, factorize it and cancel it out. If you don't still find, see whether you can multiply it by conjugate and see the factorization. If that is the case, use that. So that is a sub technique under technique 2. And of course, there is a technique 3. If it is something to do with the limit to the infinity, right? Limit to the infinity. Most of the time what will happen is you will end up is infinity divided by infinity or infinity minus infinity. In that case, divide your numerator and denominator. So this is your numerator, this is your denominator. Divide both numerator and denominator by the highest power of the x value or the variable. So in this case you can see highest power is 2, right? Here 1, here 2, here 0, right? X to the power 0 is 1. The highest power is 2, therefore you have to divide by x squared both numerator and denominator, right? So what we have to do, divide it by x squared both numerator and denominator, then you ended up something like this. Now all of a sudden when you apply infinity, something divided by infinity is 0, 1 plus 0 is 1, and here something divided by infinity is 0. Now 1 plus 0 divided by 0 is something 1 divided by 0, which is infinity, right? So infinity is not the issue, only issue is infinity divided by infinity, right? Or infinity minus infinity. Now the answer is infinity, right? So similarly we did some other examples also. Sometimes we get something like 0, sometimes we get something like 2 divided by 3, etc. right? So today we are going to discuss the L'Hopital rule. That is the fourth technique, right? So that technique also we can use. We just waited until the differentiation is done. Now we have done the differentiation. Today we are going to discuss this one as well. Okay, right. So that is the first session we did. What we did in the first session, the limits. So any questions on that? Because you must not have any questions on that at the end of this session, right? Of course you may have some questions at the end of that day, because you learned that for the first time, but now you had about 1 week's time to think about it. Now either you must have understood it, or you must have all the questions that you want to clarify. Any questions? So don't be shy, right? Any questions? So I hope then you are not belong to that type 2 category, silent people. I hope that you are in the type 1 silent people, right? The people who have understood and they are silent because you have understood, right? Okay, so then let's move on to the second topic that we discuss. The second topic that we discuss is this application of calculus. One of the application, that is differentiation, right? Differentiation. So we discussed that we are really interested about the rate of change, right? Rate of change, because rate of change of displacement is velocity, right? Rate of change of velocity is acceleration, and of course we are interested about the rate of change of the economic growth, or the economic growth of a country, rate of the economic growth, rate of the inflation, the rate we are increasing the profit of our business, right? So the rate where the epidemic or the COVID or the coronavirus is spreading, right? So things like that. So whether it's spreading like this or spreading like this, right? It's all about rate of change, right? Whether it's spreading like this, for some countries it was spreading like this, some countries spreading like this. So here you can see the rate of change is higher, rate of change is lower, right? So we are interested, right? So to take decisions, right? So therefore we discuss that. Of course, when the function is really straightforward, like straight line or whatever, we can do that very easily. We can do that very easily. But when things are getting this kind of weird shapes, we need the concept of differentiation to find the rate of change at any given point. Okay, at any given point, right? So that is where we discuss about differentiation, right? Differentiation. So again we discuss if it is a constant function like y equal 4 or something like that, obviously the rate of change is what? Rate of change is 0, because there is no change, it is the same value, it is the same value. The rate of change is 0 in that kind of situation. If it is a line parallel to the x-axis, right? If it is a line parallel to the x-axis, the rate of change is, so that is the first thing you have to understand, right? So that is where we got d by dx of a constant is 0, because there is no rate of change. If you take this as a straight line, this is y equal 0 times x plus 4. So you can see m is 0. So m is your gradient or the rate of change. Yes, obviously it is 0. That is why we say y equal 4, because it's 0 into x, right? So we say that the differential of c is 0. That is the first differentiation you learn. Rate of change of a constant is 0, and rate of change of constant is 0, right? So that is, you don't need calculus, right? So just assume that this is the notation we use to represent rate of change, right? So rate of change of a constant is 0. So just look at this as a notation. Look at it as a notation. So it represents the rate of change of this function. Of course, the rate of change of this function is 0, because there is no change. It's the same value, right? So you have to keep thinking, right? Unless until you got it, right? Until you got it, right? So not until the timeout or whatever, or else you can ask someone else, your friends, he may have understood it, right? So ultimate your objective is to understand, right? So that is where your confidence boosts, right? Confidence is increased, right? So otherwise you might get a degree or certificate or whatever, but you are not a very useful person to the society, right? Actually you will become a burden to the society. So that is bad about education. So education is not only good thing for, it's a double sort of a, it has two edges. If you do it in a proper way, you will become a really good resource to the society. If you do it in a bad way, you will end up as a burden to the society also, right? So in Sri Lanka, that is the real case in most about 80% of the time. Okay, so right, so you don't want to end up like that, right? So that is constant function. Then if it is something like a straight line, right, y equal mx plus c, you can see it's change in a steady rate or constant sort of a rate, not 0, a steady rate, same rate. In that kind of situation, if it is something like y equal mx plus c, y equal mx plus c, we know that the rate of change is same, right? We know that the rate of change is equal x. So that is why we say d by dx mx plus c equal m, because it's changing at the constant rate. So it can be the tan theta. So not can be, the value is the tan theta. If it is y equal x, if it is y equal x, we know that tan theta, it's 45, tan 45 is 1. Then we say d by dx x equal 1, because it's going at 45 degree. So this value and this value is the same. The tan theta is 1. Tan theta is 1 means gradient is 1, right? So that is the second differentiation we discuss. Of course, if it is 2x, it is 2, because you have higher gradient. If it is half x, it is half, etc. Okay, so that is something you have to understand using your knowledge on a straight line, right? Linear algebra, etc. Right? Linear algebra, etc. Right? And then you have to understand that now this is where your trigonometry, all of a sudden your trigonometry comes, right? So under trigonometry you have learned that there are three trigonometric ratios, right? So what is known as, so now if you are weak in trigonometry, now you are in trouble, right? So don't say that I can't understand calculus. You have made a mess of your trigonometry there, right? So there are, remember you learn three type of trigonometric ratios: sine theta, cos theta, and tan theta. Right? You know that if you have something like this theta, so this is called the opposite, this is called the base, and this is called the hypotenuse. So what is sine theta? Opposite divided by hypotenuse. Now cos theta, base divided by the hypotenuse, and of course the tan theta, opposite divided by the base. Right, now you can see this opposite divided by the base is the rate of change if it is a function, right? So therefore when it comes to rate of change, we are interested about tan theta, right? We are interested about the tan theta, right? Because that is the rate of change, right? So whether it's a steep or not steep or whatever, right? So we are interested about tan theta. So when I say y equal mx plus c, m is basically tan theta. Tan theta. So that is your graph, something like here. If you have theta, your m is basically tan theta. That is some y value divided by x value. If you take any y value and x value, it is going to, that ratio is going to be the same, and we call it the m value or the tan theta value. Okay. So that you have to understand, right? So that you have to understand. If you have the commitment, or if you have that curiosity, you will understand that okay, if it is a straight line, that tan theta is going to be the same, because always it is just, we are going to end up with the same ratio. So that is why where you learn in your O level, right, ratio theorems and etc. under your geometry, right, to get that done, to get those things. Okay, right. So just 1 minute. Okay, so if you are not really confident about trigonometry, you can ask those things also, right? You can ask those things also, because if you are weak in these things, of course, you are going to end up in not understanding the calculus as well, special differentiation. Okay, special differentiation, and also you have to remember that there are some. Now remember, so first you have to understand these basic things. Not only that, what is the meaning of sine, cos and tan? Why we have these ratios? So we have discussed those things in your semester 1. Why we have ratio called sine theta? Why we have ratio called cos theta? Why we have ratio called tan theta? Right? Why mathematicians define these ratios? Right? So that if you don't have those answers to those questions, of course you have not properly understood your math yet. Okay, trigonometry yet, right? So why we have ratios like sine theta, cos theta, tan theta? So can anyone answer that question? Why we have a concept called trigonometric ratios? Otherwise you are not learning. Otherwise you are not learning. Why do we have trigonometric ratios like sine theta, cos theta, tan theta? Anyone? So using Pythagoras theorem, right? If you are given two sides, x and y, you can find the third side. Or if you are given z and y, you can find x. Right? If you are given x and z, you can find y. So that is all about Pythagoras theorem. Z squared equal x squared plus y squared. That is good, but there are situations you don't know the two sides. What you know is something like one side and this angle. Then you want to find what is this value, what is this value, etc. So now you can see Pythagoras theorem is not going to help. Right? Pythagoras theorem is not going to help. Therefore, mathematicians came up with this sine, cos, tan ratios. Now, if I want to find this one, we know that say this is something unknown. Tan theta equal that unknown divided by x, and we know theta, we know x, and assume that we know what is tan theta using table. Then all of a sudden we know that u equal x tan theta, so that is why we have this sine table, cos table, tan table. And of course if you have calculator, you can always find the tan value, sine value, cos value of any angle, right? All of a sudden you found it, all of a sudden you found right? Of course if you want to find this, you can write something like cos theta equal this divided by this. Now because you know cos theta, because you know x, now you found this. So that is why we have trigonometry, right? So in order to facilitate that calculations, right, because there is no theorem connecting those things, they came up with this table to work with that. And also it results in a lot of good results also, though you can't exactly say, there is no mathematical way to find the tan value. That is why we keep it in a table. And of course you can find sine, cos, tan value of well-known angles like 30, 45, 60, 90, right? So that is another thing you have to remember. Actually those things you have to remember and understand, right? 0, 30, 45. So if you don't know these things, you can't figure it out or interpret the value of your differentials. 45, 60, 90, right? So you know that sine 0 is 0, sine 30 is half, 1 over root 2, root 3 over 2, and 1. And of course the cos value 1, root 3 over 2, 1 over root 2, half, 0. And tan value is this divided by this, 0, right? 1 over root 3, 1, root 3, and infinity. Again you can see 1 divided by 0 is what? Infinity, right? So those things you have to understand, right? If you don't understand, now all of a sudden you have another thing you have to understand is, so first you have to understand what is the sine, cos, tan value of these things. Another thing you have to understand is, so when it comes to bigger angles, right? So you know that here only sine is positive, here only tan is positive, here only cos is positive, sorry, here all are positive, right? Here only sine is positive, here only tan is positive, here only cos is positive, right? So all sine, tan, cos. So that means if you take something like bigger angle, it's only tan is positive, sorry, sine, all sines, only sine is positive. That means that this sine theta is positive, but cos theta is negative, tan theta is negative, right? So because it's only sine is positive. But if you take a small angle, right, its sine value is positive, cos value is positive, tan value is positive. But if you take this kind of angle, because it is in this quadrant, right, only sine is positive. That means its sine theta is positive, but cos theta and tan theta is negative. Right? If you take something like this, now it is in the so something like this. So let's draw it again. Third quadrant. So not like this, not like this, something like this. Okay, something like this. Now you have to take this angle. This angle. Now all sine, tan, cos. Now tan is positive, but sine and cos are negative. Sine and cos are negative. Right? So I think I made a mess of it, because this is same as the other one, right? So let's see, sine, cos. Yeah, so the big angle is the tan is only positive, right? Tan is positive, right? So likewise here again only cos is positive, others are negative. So all sine, tan, cos. So you have to understand that also, right? And of course you have to understand the graph of sine, cos, and tan, right? So then only you can do really serious things, right? So the sine curve. So sine curve goes like this. Sine curve goes like this forever. Here also it goes like this forever. Right? So it's same thing, right? So I will just show it in your So those background also you must have, right? Especially if you are not done, if you have not done maths, those who have done maths have that background, right? So this is how your sine curve looks like. Sine 0 is 0, sine 90 is 1, again sorry, sine 5 or the sine 180 is again 0, right? It goes like that. So that is called sine curve. So that is what happened in your electricity also. We have sine curve. Then cos curve, right? Then you can see cos 0 is 1 but cos 90 is 0, right? So it is something like this. It is something like this. Now you can see sometimes it is negative, sometimes it is positive. Now it is mapped to that all sine tan cos, right? All sine tan cos, all sine tan cos. You can see here for greater values sine is positive, right? So of course that is 5 by 2 to or 90 to 180. You can see from 90 to 180 the values are positive. You can see values are positive. So that is why we say sine is positive. But if you take cos, right? If you take cos from 90 to 180, cos is not positive, right? Cos is not positive. You can see that from 90 to 180 cos is negative, right? Cos is negative, you can see. So that is why we say it's only sine is positive, right? But again here cos become positive again. You can see cos become positive again, right? So likewise you have to draw these graph and compare with this and right so on. So if you have done those things, you are done, right? You have that basic understanding, right? Again, if you take tan, you know that tan goes to infinity also, right? Tan 90 is infinity. So tan graph is something like this. Now you can better understand these things because you have understood the limit also, right? So here you can see tan, here positive, here negative, here again positive, right? So you can see this is 0 to 90 positive, right? Then from 90 to 180 again negative, but once it becomes 180 to 270, again it is positive. 180 to 270, again it is positive, right? Again positive. Then it again become negative because only cos is positive, right? So likewise it is always good to know the shape of sine theta, right? Sine theta, cos theta and tan theta, right? So now because you have learned limits, now you can understand this tan theta because now you know what is infinity, right? Right. So those things also you need if you want to get full marks, right? So that is what is your target, right? So get a or get a plus, right? If you want to get A or A plus, if you are aware of this graph, shape of this graph, you are in good shape. You are in good shape, right? So I am now covering those additional things. Okay. Of course, I covered the concept of limits and differentiation last time, but there are small things, additional things you have to understand. Actually you should have understood these things in your previous semesters. Just I am reminding that. Okay, so think about those things now again little bit seriously because you have done calculus. Okay, you have done calculus because the examiner is going to check those things as well, right? So now what few things we added, you have to be really confident about the straight line, right? So you must be really confident about the straight line, and of course the sine cos tan value, and of course the y equal x squared, y equal minus x squared, y equal x squared plus c, etc. Then the final thing you have to be straight line, the parabolic shape, right? Sine cos tan, right? So sine cos tan. Then we added one more, 1 over x, right? 1 over x, something like this. 1 over x, y equal 1 over x. So what is the other thing? So that's it, right? Straight line, sine cos tan, y equal ax square plus bx plus c, that is a parabolic shape. 1 over x, right? So just one more you are expected to know, that is ex graph. That is ex graph. Then you are done with your graph, right? So ex graph. So how do you draw the ex graph or the ax graph? So if you have something like this, your ex is something like this. It's a special graph. Y equal ex graph, right? Ex. So E is the Euler number, 2 point something, right? So that number is when you substitute x equals 0, e to the power 0 is 1, so that value you get is here, what you get is 1, because anything to the power 0 is 1, right? So if you want to get the Euler number, you have to substitute 1 here, so somewhere here you will get that irrational number, right? 2 point something, if I remember correctly. Okay, right? So that is special value e, but if you take general value a, it becomes a to the power x. A to the power x, again the shape is the same, but the gradient might different, or the shape, the real shape might different depending on the value of a, whether it's 1 or 2 or 3 or 4, whatever, right? So the general one is y equal a to the power x. The special case is y equal e to the power x. Now can someone tell me why we are interested about, of course we are interested about y equal a to the power x, but why we are interested about y equal e to the power x? So if you can answer that, of course we are talking about y equal a to the power x, and all of a sudden we are talking about a special case called y equal e to the power x. Now you have to ask why we are talking about this special case. Can someone answer that question? Right, of course if it is 5 to the power x, you can draw it. If it is 10 to the power x, you can draw it. Now if it is why we are interested about y equal e to the power x, and e is the Euler number. So the reason is it's a special case where your gradient is also e to the power x. So that is d by dx e to the power x, also we got the value x. So that is really interesting result, right? So when you differentiate a function, if you get the same function, that function is the Euler function, right? E to the power x. So that is why e is a special number in maths, right? So when you differentiate x, what you get is 1. When you differentiate x squared, what you get is 2x, something different. When you differentiate sin x, what you get is cos x. But when you differentiate ex, what you get is ex. Therefore ex is a really interesting function, right? Very very interesting function. That is why we are interested about ex, and that is why when we are taking logarithms, right? When we are taking logarithms, we say that, of course, log a to the power whatever, that is normal logarithm. A can be 10, then the normal logarithm of base 10, a can be 20, a can be 5, but if a equal e, we say that is natural logarithm, right? ln x, right? So that is e. So taking logarithms of base e is also very interesting because it has this feature. So that is where we discuss that. Of course, if you differentiate ln x, that is log e to the power x, what we get is 1 over x, right? What we get is 1. So these are the things that you learn, right? So that is special case rather than log ax. Of course that is general case, but this is an interesting case where you get a very interesting result, 1 over x, just like e to the power x is e to the power x, right? So likewise you have to appreciate there are special cases also, right? So therefore make sure that you know what is e to the power x graph look like, and also you know what is the shape of the ln x, right? So that's something you learn in your semester 2, so semester 2 maths, right? So I hope you have done those things properly. Remember, you learn in relations and functions, you learn that we have something called inverse function, right? Inverse function. So then what is mean by inverse function, right? Inverse function is the mirror image under a y equal x line, right? Y equal x line, right? So if you have something like this, the inverse function is something like this, right? Mirror image, right? So if it is fx, this is f inverse x, right? So what is the connection between ex and ln x? Ln x is the inverse function of ex, right? Ln x is the inverse function of ex. So that is something you have learned in your semester 2, right? And of course semester 1 also, because you learn logarithms, of course semester 2. Now it's in semester 1 on new syllabus. You learn the logarithms and indices, right? So that's something you have to remember, right? Something you have to understand, right? So, and you can experiment. Now this is your ex, I am using the calculator. This is e to the power x, something like this, right? Something like this. Okay, so just 1 minute. Okay, so just 1 minute. Give me 1 minute. Right. Sorry. So this is y equal e to the power x graph. Now, as I told you, ln x is the inverse function. So in that case, what is going to happen? Ln x is going to be the mirror image under e to the power y equal x graph, right? So let's draw the y equal x graph as well. So that is y equal x graph. Now let's draw the ln x graph, right? Ln x graph, ln x. Now you can see, yes, it is the mirror image. Now if you are doing calculus, you must understand this concept that you learn in your semester 2, right? This is the shape of e to the power x, and this is the shape of ln x, right? So I will show it. Right, now you can see this is e to the power x. This one also I want to show. So you have to do these things. You have all these tools, right? When we were doing our studies, we never had this kind of interactive tools, right? So we learn those things in hard way, right? We learn these things in a very hard way, but you can learn it in a much soft way, right? So why don't you use those tools, right? Don't learn the things the way we learn, right? Of course, we never had these tools, but you have all these tools. Right, so this is ln x, right? So this is ln x, this is e to the power x, and of course this is pi equal x. Of course, I am not talking much about calculus. I am more talking about other things, background, right? Background, because that is important, right? So now you can see, so you have to understand the shape of ln x, shape of ex, and you have to understand that it is the mirror image or the inverse function. So that is why you learn something called inverse functions, right? In your semester 2, right? Semester 2, right? So if you have understanding about these shapes, right? So it's when it reaches to infinity, it goes to infinity. When it goes to minus infinity, ex is reaching to 0, right? When it comes to ln x, when it goes to infinity, it goes to infinity. When x is reaching to 0, it is going to the minus infinity. So those things you have to understand, right? Those things, if you understand those things only, you can do some of those questions. Okay, right? So now, so therefore now how many things you have to know, right? How many functions you have to know? Of course, you have to understand the behavior of a straight line, y equal mx plus c. Of course, the constant line, right? Constant function, so the straight line. Then the parabolic shape, y equal ax squared plus bx plus c, whether, right? Then the trigonometric function sine cos tan, right? Then 1 over x, then the ex and the ln x, ex and the ln x, something like this, that's all, right? So that is expected in your exam. So your examiner expect that you know the properties of straight line, you know the properties of parabolic shapes, you know the properties of sine cos tan, shape of their functions, you know the properties of 1 over x, and you know the properties of ex and ln x. Of course, if you take general case, ax and log ax, right? Shape is going to be the same, right? And why ex is special? Of course, because the gradient is also the same function, okay, same function. Right, so likewise, so that's all, right? So I am not asking you to remember any other shape, because I know the syllabus. I know your past papers about more than 10 years. The examiner assumed that that you have this basic understanding about the shapes, right? Straight line, parabolic shape, sine, cosine, 1 over x, ln x and ex. Okay, so I don't want anything else. Of course, if you know some other relations, that is okay, but for the exam you must have this minimum thing, right? Minimum thing. Okay, right? So then so let's move on. Of course, the revision is taking more than 1 hour now, right? Because doing question is, of course, you can do it, right, as long as you understand the things. Anyway, I have uploaded all these answers to Google Classroom, right? So therefore you can go through by yourself also. I have uploaded all these this document to the Google Classroom, right? So I am just facilitating, so I am not going to spoon feed, right? Taking one question, this is how we are going to do it, right? That is called spoon feeding. It's not going to work. I am a facilitator. I am facilitating you to start thinking, right? So you have to think, you have to learn, right? So you have to think, you have to learn, because I know that spoon feeding is not going to work, right? So it is not going to work, right? So therefore this is the only way we can you can understand these things. Okay, right? So let's move on. Then we discuss so of course we discuss what is mean by rate of change from the first principle. So there is an error somewhere here, but as long as we are making delta x closer and closer to the error 0, this error becomes negligible. Then all of a sudden we can say delta x tend to 0, fx plus delta x minus fx minus delta x is it becomes the gradient of this tangent, and we can call it the derivative of the function. So what is the use of derivative of function? It gives the gradient of the tangent at particular point. So while fx is giving you the y value, your d by dx, so f dash x is giving you the gradient of the tangent at a particular point. So that is very important concept, right? Very important. Of course, from first principle also we discuss how to find the derivative of c, how to find the derivative of x, how to find the derivative of x squared, right? I gave you as a exercise how to find the derivative of x cubed, right? You must get 3 squared. So likewise, that is to build your confidence, right? Build your confidence. So what we do, again we factorize and we cancel out the delta x or h or whatever the value, then you get something like that. So that is the rate of change function. So you have the function and you get the rate of change function. So if you want to find the rate of change at a particular value, you substitute that value here. If you get 5, the rate of change of this function at that particular value is 5, right? So if you get minus 2, rate of change is minus 2. What is mean by minus 2? That means it's a negative big angle, right? So big angle, that is tan theta is negative, right? So positive means something like this shape, rate of change is something getting increased, negative means it's getting decreased, right? So likewise you have to understand, right? So gradient is positive means it's getting increased, right? Gradient is negative means it's getting decreased. That is why it is now you can see it's a bigger angle, and we know that all sine, so only sine is positive, here tan is negative, that is why we are getting negative value, so it's getting decreased, right? Now you have to interconnect all those things together, right? So then you have the trigonometry knowledge, right? So that is why I told you in the very beginning, in order to properly understand or properly interpret your differentiation, you must have that basic understanding of trigonometry, right? So that is why we say you can't start maths from somewhere middle, you have to start from beginning, very systematic way. So those who have that systematic knowledge, they are really confident, okay, right? So you can't enter into the maths in the somewhere in the middle, right? So that is why your from school level, that foundation is really important, okay? So that logical thinking, right? So then of course we discuss some important derivatives, right? X squared and the interpretation of that. Then we discuss some rules also, right? So you can, if you have constant, you can take it out. If you have summation, you can do the derivatives and sum. Subtraction, you can do the derivatives and subtract. Multiplication, first into second derivative plus second into first derivative. Division, bottom into first derivative minus top into bottom derivative divided by bottom square, right? So we did some examples for those. Then of course very important rule we discussed, the chain rule. Actually I did it only very last minute, right? Only very last minute, because I knew that a lot of questions are from the chain rule. Anyway, we are going to revisit that again, right, while doing the past paper questions, right? Chain rule, right? Right. So for example, let's take a quick revision on this. If you want to do something like this, right? So then of course we discuss we'll come back to the chain rule later. Then we have to understand or remember few well-known derivatives, right? Not few, actually about somewhere closer to 20, right? The derivative of constant is 0, that we understood using the first principle as well as looking at the graph. Derivative of x is 1. Then we generalize it. Derivative of x to the power n is nx n minus 1. So that means derivative of x cube is 3x squared. Derivative of x5 is 5x4. So this n can be negative, positive, or even fraction, right? Then of course that our good friend the Euler constant, derivative of ex is ex, right? Then its inverse function, derivative of ln x is 1 over x. So now you can see it's a story, right? It's a story, right? So why we are interested? These are very special functions in maths, right? And of course the general case, right? These are the special cases that behave really interestingly, and this is our general case, right? So ex is special case of ax, because e is a special constant, a is a constant, any constant. And then d by dx ax is ax ln a, d by dx log ax is 1 over x ln a, right? Then the sine, cos, tan values. Derivative of sine is cos, derivative of cos is minus sine, derivative of tan is sec squared x. Then the cosec sec counterparts. The cosec derivative is minus cosec x cos x, the derivative of sec x is sec x tan x, derivative of cot x is minus cosec squared x. Okay, so you have to remember these 6 also. But why you have to remember this? So all those students who are doing maths in their A level or degree level, we expect some common ground for you guys to play with, right? So everyone, if you want to discuss some idea with them, you must also remember these things, right? So then only you can work with them, right? You can think with them, right? So that is why you have to learn, remember these things as well, because otherwise you can't work with them, you can't discuss with them, because they know what is mean by derivative of cosec x, right? So we want you to be in that same club, mathematical club, right? So the mathematicians club, right? So that is why. So don't take this as a another burden or something, right? So anyway, don't put a lot of effort. Naturally you will understand, remember these things if you are really interested about this, right? Then if of course I told you optionally, if you can remember, better remember this, right? Of course you need this when you are doing the integration, in some integrations only, right? If you feel like this is too much, okay, forget about it. There is a very small percentage or probability of you need these 6 for the exam, but of course this 6 and this about small things, about altogether about 15 rules you have to remember, right? So I don't think that is a big thing, right? I know that if you have done bio, you have learned from, right, thousands and thousands of things you have memorized, right, in a very miserable way. So this is maths, this is you have to remember only few things. So just remember those few things, and more than that, understand those concepts. Okay, understand those concepts, right? Then we did some exercises also, right? So how to apply those things, the quotient rule, multiplication rule, summation rule, subtraction rules, etc., and of course the chain rule, right? So at the very end we did the chain rule. Anyway, we are going to do some more examples today, right? Then of course we discuss the higher order derivative also. We can again differentiate a function, then we get the rate of change of that rate of change. So it's something like rate of change of displacement is velocity, that is first derivative. Rate of if you want to find the rate of change of velocity, you have to do the differentiation again, because that's the rate of change, what we get as acceleration. Okay, so then you have to do differentiate again, right? So that is very interesting concept, right? So likewise we can differentiate any number of times, that is the rate of change of blah blah blah, right? So because maths is all about abstracting things, Maths is all about generalizing things. Of course, most of the time we are only interested about the rate of change and the rate of change of rate of change. But in maths, we generalize it to saying that we can differentiate up to n, right? N times, right? So 2 times, 3 times, 4 times. That is to make you more abstract person. Understand, generalize those concepts in a very abstract way, right? Right. So we discussed that also, and we did some example also, very interesting example. This is very important, right? Interpreting the rate of change and its results, whether it's positive, negative, etc. Right? Right. Then we discuss, by using those derivative values, we can find whether we have critical points. So what is mean by critical point? It can be a maximum, it can be minimum, or it can be a point of inflection, right? Point of inflection. So maximum, minimum, point of inflection, those are called critical points. We can find whether where are our critical points using the derivatives, right? So we discussed that there are two tests: the first derivative test and the second derivative test, right? So the first derivative test says, if you are moving from positive to 0 to negative, your first derivative, it's a maximum, because now you have to understand the trigonometry. Positive means small angle, 0 means parallel line, negative means big angle. So if you are going from positive, 0, negative, that means you have a maximum, right? Again, negative, positive, negative, 0, positive means you are passing a minimum. But if it is a positive 0 positive or negative, positive 0 positive or negative 0 negative, it can be a point of inflection. There are four possibilities. So we discussed that last time. It can be something like that. It can be something like that. It can be something like that. It can be something like that, or it can be something like that. Right? So all those positions, now you can see this is negative 0 negative. This is positive 0 positive, positive 0 positive. So this is positive 0 positive, two possibilities, and negative 0 negative, two possibilities, right? So we can't say exactly what is the possibility, but when it is positive 0 positive, we know that this one or this one. It's negative 0 negative, we know this one. But if it is positive 0 negative, we know exactly it is a maximum. Negative 0 negative, exactly it is a minimum, right? So that is the first derivative test. And then we discuss the second derivative test. There we combine first derivative and second. Here we just have to look at the first derivative only, but only thing is you have to look at that point little bit lesser than that, little bit bigger than that. That point little bit lesser than, little bit bigger than. That point little bit lesser, little bit bigger. So that is the first derivative test. But when it comes to second derivative test, we just have to look at the point itself only. But we have to look at both first derivative and second derivative. If the first derivative is 0 and second derivative is negative, that is a maximum. If the first derivative is 0 and second derivative is positive, it's a minimum. If both are 0, it can be one of these four situations, right? It can be one of those four inflections. Again, we can't say exactly what is the situation. Of course, there are some other tests to do that. That is not beyond your syllabus. But we can say that it's a point of inflection when both are 0, right? Okay, so that is how we discuss, right? So then of course we didn't do the Hospital rule, so let's do that after doing some past paper questions. Now let's move on to the past paper questions. Okay, right? So now I can very quickly move on with the past paper questions. Of course, some questions are easy, some questions are difficult. That is why yesterday I put a small note to your WhatsApp group mentioning which questions are easy, which questions are moderate, which questions are difficult, because I don't want you to get frustrated by first doing difficult questions, right? So I want you to do first some easy questions, then do some difficult questions, right? So I will also take the easier questions first, then I will do the difficult questions later. Okay, so these are the past paper questions I extracted. So all the past paper questions related to in last 4 years related to so actually there was only one questions related to limits, all the other questions are related to differentiation. Of course, I didn't take the integration questions because still we haven't done that, right? So I will first take some easier questions. Okay, right? So sometimes, so I have given you some additional information, right? So that is not needed to do the paper question, but I am giving you some additional information as well. So let's take some simple questions first. right? So let's take this question first, and this is question MCQ question 15 in your 2019 paper. That means last year paper, right? So they have given you the fx value, right? So I will just copy this. Okay, can't copy from there, so let's copy it from there. So question 15. Right, so let's take somewhat easier question as a starting point. Right, so this is the question. So they have given you the fx sine 2x plus 1. They ask you to find the d4f by dx4. Now you know what is meaning of d4f by dx4. That means you have to differentiate this 4 times, right? So let's do it. So this is a very simple questions, right? So your fx is sine 2x plus 1. So you can't find d4f by dx4 straight away, so let's go one by one. So let's differentiate it with respect to x one time. So that is dfx by dx, that is the short, we use the notation f1 x or f dash x. That means we have to differentiate this d by dx sine 2x plus 1, right? Of course, we know what is differentiation of sine x. What is the differentiation of sine x? Cos x. But what we want to differentiate is not sine x, sine 2x plus 1. And that is where you have to use the chain rule. Remember, chain rule says you can think of this as a x and differentiate, but make sure you multiply it by the differentiation of what you thought as x. Right? So now let's think it as x. Now all of a sudden what you see is what? D by dx sin x, and we know that d by dx sin x is what? Cos x. But as a x you have to write this, so therefore cos x, right? But x is 2x plus 1, but we have to make sure that you multiply it by what you thought as x. What you thought as x is 2x plus 1, right? Now the answer is cos 2x plus 1, and of course now it is d by dx 2x plus 1. Now you can apply the summation rule, right? So if you want, you can do it in steps, but once you get familiar, you can straight away write it as 2, right? So let's do it in a long way. D by dx 2x plus d by dx 1, right? So now it is cos 2x plus 1 into, and we can take this constant out, then d by dx x is 1, so therefore that is 2. Here it is 0, right? Here it is 0. Right? So here it is 0, because differentiation of constant is 0. Now what you get is cos 2x plus 1 into 2. So I can write it like 2 cos 2x plus 1. So that is your first derivative. Actually I did it in a long way. Once you get confidence, you can just write it in a straight away. You can say cos 2x plus 1, differentiation of 2x plus 1 is 2, therefore 2 cos 2x plus 1. So that you get the confidence once you do some questions. Now we have the f dash x, Right now we have the f dash x. Right, so what we got as f dash x is 2 cos 2x plus 1. Right, now what we need is not f dash x, f differentiate 4 times, right, differentiate 4 times. So let's keep moving, keep doing that. So again I am going to differentiate this, therefore I am going to get f2x. Now I am using the constant, I can take it out, so I am taking it out, and I am using the chain rule here. If I use the chain rule, I can see it as cos x. We know that differentiation of cos x is minus sin x, so therefore I am writing it as minus sin. I am thinking this as x, therefore I am just writing it 2x plus 1, but I have to multiply it by what I think as x, that is 2x plus 1. So differentiation of 2x plus 1 is 1, 2. Right, so that is 2. Right, so what I got is minus 4 sine 2x plus 1. 2x plus 1. So that is my f2x. Right, now I have to go up to f4x. Right, so now let's do it again, differentiate, and then I will get f3x. Again I can see there's a constant, I can take it out, then I am differentiating this one. Again it's something like sin x. If I think this as x, right, then all of a sudden it becomes sin x. Sin x derivative is cos x. Cos, what I think as x I have to write, but I have to multiply it by what I think as x, that is d by dx 2x plus 1, that is 2. Right, now it is minus 8 cos 2x plus 1. 2x plus 1. So what I need is the next one, f4x. So let's do it again. Let's do it again. F4x. Again minus 8 is a constant, I will take it out. Now I can see d by dx cos x. If I take it as a block, derivative of cos is minus sine. Minus sine 2x plus 1. I have to multiply it by what I thought as x, which is 2x plus 1. Derivative of 2x plus 1 is 2, because I can take the constant out, then this is 1, and here derivative of constant is 0. 2 plus 0 is 2. Right, so you can do it once you get familiar. Then minus into minus is plus, 8 into 2 is 16. 16 sine 2x plus 1. So that is my final answer. Right, so that is what they ask you to find. 16 sine 2x plus 1 is my answer. So let's see the answer. So 16 sine 2x plus 1 is answer B. Right, right, so that is B. Of course D is also answer. Why is that? Of course, so you can see this is a multiple answer question, so don't miss that also, because it's a multiple answer question. 16, if you want, you can write it like what? 2 to the power 4. So don't miss that marks also, right? Otherwise you are going to get only half of the marks, because 16 is 2 to the power 4. If this is answer, this is also answer. Right, so this is also answer. Anyway, I have given you the detailed steps here. Right, I have given you the detailed steps here. Right, so showing you how to differentiate those things using the chain rule. Right, so this is not a difficult question. Actually, I took this as the easiest question in your 2019 paper, because just you have to do derivatives repeatedly. You have to use the chain rule. You have to use the chain rule repeatedly. So if you have any questions, you can ask. Right, so it's something like this. So remember last time we did this kind of questions. If you want to find the derivative of d by dx x plus 1 squared. Now you don't know what is x plus 1 squared, but what we know is the derivative of x squared is 2x. Now you can think of this as x. Right, you think of this as x. Right, then all of a sudden it looks like x squared. We know that derivative of xn is nx n minus 1, that is 2. What you think as x, you have to write x plus 1 1, because nx n minus 1 2x, but what you think as x is x plus 1, therefore you have to apply the chain rule and multiply it by what you think as x plus 1. Right, so now answer is 2 times x plus 1. Now of course you can do the derivative of this plus derivative of this. Derivative of x is 1. plus 0. So 1 plus 0 is 1. Answer is 2 times x plus 1. So answer is 2 times x plus 1. Now you can see, right? So that is chain rule. That is chain rule. Now what you want to double check whether this is correct is you can apply it by first expanding. So let's expand it. So if I expand this, I can write it like d by dx x squared plus 2x plus 1, right? Because x plus 1 squared is this. And now I can just do the derivative of this plus derivative of this plus derivative of this. So that is d by dx x squared plus d by dx 2x plus d by dx 1, d by dx 1. Right? So d by dx 1. So what you get is x square derivative is 2x plus 2, I can take it out, then d by dx x is 1, 2, here derivative of constant is 0, so 2x plus 2. So 2x plus 2 is what? If you take x2 out, x plus 1. Now you can see this answer and this answer is the same. So here we use the chain rule and do it. Here without doing the chain rule, first we expand and did the derivative. You can see we are getting the same answers. That of course that is not a proof of chain rule, but it convinces you that this chain rule is correct. That is why we are getting the same answer. Right? That is why we are getting the same answer. Okay. So similarly, if you are asked to do something like this, so chain rule I am little bit doing, right? If you are asked to do d by dx sine x squared. Now you don't know what is sine x squared, but what you know is sine x, derivative of sine x is what? Cos x, right? So just think of it as x, then all of a sudden you can say cos x squared, but now you have to multiply it by what you thought as x, which is x squared, right? So we know that derivative of x squared is 2x, therefore it is cos x squared 2x, but this is not, you are multiplying by this, therefore usually what we write is, we write it like 2x cos squared x. So that is your answer, and that is your answer. So derivative of this is this. Again, if you are asked to do something like find the derivative of d by dx sine of tan x. So don't get scared. හරි බය කරනවා පොඩ්ඩක් පේපර් එකේ. මොකද බය නැතිව අපි ෆීල්ඩ් එක ලගන්නවා. අපි බය ආව තියලා යනවා. මොකද බය ආයත් එක්ක IT කරන්න බෑනේ නේද? බය ආයට තියෙනවා මල් වගාව, හරි මනාලියන් ටැන්ඩියම් වගේ soft දේවල්. හරි. Right. So this is for those who have guts to do complex things, right? Now again you can think of it as x. Right? You can think of it as x. Now all of a sudden it's sin x. You know that derivative of sin x is cos x. Cos, what you think as x you have to write cos tan x. But since you thought it tan x as x, you have to multiply it by derivative of what you thought as x, that is tan x. And that is cos tan x. And then you know that derivative of tan x is what? Sec squared x. So that is your final answer. So answer is sec squared x cos tan x. Right? So that is why we learn composite functions. F of gx. That you can do, right? So sine of cos x. So first you find the tan x, then you find the value of cos x. So don't try to understand what is exactly this. This is just we can find the derivative function, right? Right. So let's move to the past papers again. Right, so let's do another question. I'm just taking the easier questions first, right? Mixture of easier questions. Right, so they ask you to find this. So this is from your structured paper 2019, right? So 15 marks are there, right? So 2a, find the derivative of fx equal xn ln x. So let's do that. Now of course you have to remember the derivative values, right? Otherwise you can't do this. So let's do it. Right. So you are supposed to do this. Find the derivative of fx equal xn ln x. So just you have to differentiate once. So let's write it down. Let's take the pen. Fx equal xn ln x. So let's differentiate, right? Differentiate with respect to x. Then what we get is f dash x or d by dx, this function. So let's write it as f dash x. Now you can see there is a multiplication. This one I know what is the derivative of x to the power n. What is the derivative of ln x? I know this is nx n minus 1. This is 1 over x, right? So therefore we can, what we think is as multiplication, and we know the multiplication rule: first into second derivative plus second one into first derivative. So let's write it: first one into derivative of second one. So once you get the confidence, actually you can write this straight away, right? So you can skip this one also, but for the time being, let's write first into second derivative of second one plus second one into derivative of first one. Derivative of first one. Now we are almost done. So x to the power n. We know that the derivative of ln x is 1 over x plus ln x into, and we know the derivative of xn is n x to the power n minus 1. So now you can use the indices rules. So this will be x to the power n minus 1 plus, usually otherwise you will get confused thinking that this is multiplied by this one, right? So therefore we take this one at the beginning, nx n minus 1 ln x. So that is your answer. So if you get that answer, you will get the full marks for that. I think 10 marks. So that is the question. So you have to get something like this. So not 10 marks, 15 marks. You can say that is not a difficult question. Just can you do you remember the multiplication rule? Even the chain rule is not needed. And can you remember what is the derivative of x to the power n? What is the derivative of ln x? And a little bit of indices. Very basic indices, right? So I hope you can tackle those kind of questions, right? And this is somewhat difficult question. I'm just keeping it because it's not difficult actually. You have to you must be brave enough to continue simplifying. So this question basically check whether are you brave enough, right? For example, when you are doing your software development, when you get a weird error, are you brave enough to dig into that and find out what is the error is, or you just scared of it? So right, so we want to get rid of your scareness by looking at those complicated situations. So that is why you are given this kind of questions. I am just keeping it for later, right? So let's do this one. So this is 2018 paper. So they say that f dash x. So let's take this question. So I am taking the easier questions. I am keeping the difficult questions for you, and also because I don't want to do the difficult questions up front. Right. So what they ask is they have given you a f dash x. Now they have given you a derivative, right? So they say that f dash x why I am not getting it. Right, so they are saying that f dash x is 3 times fx, and they are asking you what can be this possible fx. Right? Now since you have given the answers, of course the answer is highlighted, you just have to look at the answers and see which answer satisfies this. That's it. Right? Which answer satisfies this. Now if you take the first one, if fx is e to the power 3x. Now this one you know, but you want to find out this one, so just find f dash x. And we know that again you have to use the chain rule. We know the derivative of ex is ex, but this is not ex, this is e3x, so you think of it as x, then e to the power x is derivative of e to the power x is e to the power x, right? But you have to multiply it by the what you think as x. What you think as x is 3x, derivative of 3x is what? 3. So 3 times ex, right? 3 times ex, and of course ex is so you have to write it as e to the power 3x, because what you think you have to write, right? E to the power 3x, because e to the power x, derivative of e to the power x is e to the power x. What you think as x is 3x, you have to write it like that, but you have to multiply it by d by dx 3x, which is 3, right? So the answer is 3 times e to the power 3x. Now you can see that e to the power 3x is fx, that is 3 times fx. Now you can see it satisfies this. F dash x is 3 times fx, so that is answer. Likewise, you have to take another one, right? If you take this one, so let's delete this. By experience, actually you can see that this is the only answer. That is why you need little bit of exposure to doing some problems, right? But if you are not really sure, you can double check, right? If fx is 2 e to the power 3x, now I am going to do it straightforward. Constant I can take it out, right? So e to the power 3x is, once you do the chain rule, you will find that this is 3 e to the power 3x. This is 6 e to the power 3x. Now 2 e to the power 3x is the fx, therefore 3 into 2 into e to the power 3x, right? 2 e to the power 3x, yes, this is the case. 2 times e to the power 3x, that means 2 times 3 times e to the power 3x. Yes, 3 into 2 is 6. I can write 3 into 2 times e to the power 3x. Yes. So 2 times e to the power 3x, I can write it as fx. So this is f dash x, okay? F dash x. It looks like it is also answer, right? So that is 3 times fx. So why don't they have taken it as answer? I think that is also answer. Let's do it again. So they ask you to find fx. So if fx is 2 e to the power 3x, the f dash x is, I can take the constant out here, 3 times, or e to the power 3x into 3. Yes, 3 into 2. 3 into 2 I can write it as 2 into 3 I can write it as 3 into 2. Then 2 e to the power 3x is fx, 3fx. I think this is also answer, right? So that just double check. It looks like this is also an answer, but I don't know why they have not taken it as answer, right? So I think that is also answer, right? So let's take the other one. So for some weird reason, maybe I have made a mistake. I hope I have not made any mistakes, right? So I think this is also an answer, but let's take C also. Let's take 3C. E equal, let's say fx equal e to the power minus 3x. In that case, f dash x is, think of it as x, then e to the power minus 3x multiplied by the derivative of minus 3x, which is minus 3. Right? You can see all of a sudden you can write, right? Then so e to the power minus 3x is your fx. Now I can write it as minus 3 times fx, but the formula says not minus 3 times fx, it is 3 times fx, therefore this is not answer, right? Likewise, you have to check all the other ones also, but it looks like B is also answer. Just double check. Let's do it again, because I am really curious why they have not taken B. So let's delete this. So I'm not just doing the question itself, I'm just giving you some background. So let's take the second one again, why they are not taken it. Let's say fx equal to e to the power 3x, then f dash x equal 2 times, this one I can write it like 3 times e to the power 3x. So that is 3 times 2 e to the power 3x. 2 e to the power 3x is the fx, that is 3 times fx. Yes, I think that is answer, right? I think that the answer sheet is not giving the correct answer, right? So B must also be answer. Let's go to the 12. I think they have not given me the answers separately for that paper. They have just mentioned it there itself. Yes, so they have given only A. Just check whether the VLE has updated answer sheet. Oh, no separate answer sheet. I think the second one is also answer. Okay, second one is also answer. Now you can look at this chain rule closely. Now I will give you a shortcut also, right? Because it's very widely used. Now close look at this. If you want to do something like this, d by dx e to the power 5x. Now you know that if you think this as x, it is e to the power 5x, d by dx 5x is 5, which is 5 e to the power 5x. Now this is heavily used, therefore you can just look at, after sometimes you will find that by experience, if you have something like d by dx e to the power ax, you can straight away write it like a e to the power ax, because you know that when you think like that x, it becomes that, then you multiply it by the derivative of ax, which is a. So always when you see something like e to the power 10x, 10 e to the power 10x, e to the power derivative of e to the power 5x, 5 e to the power 5x. So that you can just remember it, then you don't have to spend a lot of time to apply the chain rule. Again, if you have something like this, d by dx sine 5x, you can just write it as 5 cos 5x. If you have d by dx tan 10x, of course you know that tan x derivative is sec squared x, you can straight away write 10 sec squared 10x. So that is applying the chain rule, right? So if you think it as x, tan x derivative is sec squared this, then you have to multiply it by the derivative of 10x, derivative of 10x is 10. So likewise for sine cos tan ex, you will straight away write like that. It's something like if you have a constant, you can just multiply it by the constant. So this is applicable for ln x also. If someone asks you to find d by dx ln 10x, because you know that ln x is 1 over x, you can say 1 over 10x and 10 times 1 over 10x, because if it is 10x, you have to multiply it by 10. Of course ln 10x is 1 over 10, sorry 1 over 10x, so the answer is 1 over x again, right? 1 over x again, right? So likewise you can use that as a, if you have multiplied by a constant, you can take that constant, multiply that constant, then take the derivative of the normal value. Okay, so that applicable to this kind of scenarios, sine cos tan scenarios. It's a special case of chain rule. Okay, right. So let's look at some more questions. Right, so we did that. Of course, for me, answer B is also an answer. Right, so let's take this one. Right, so when you first look at it, you might feel it like a difficult question, but it is not a difficult question, right? So let's copy this. Right, so let's write down the question. So they have asked you to find the nth derivative, right? Not the first derivative. You can see nth derivative. That means you have to differentiate n times. So don't worry, you are not going to differentiate n times. You are going to say pattern and say this is going to be your answer, right? So don't worry too much. So they just check whether you have the courage. You see the patterns, right? So let's see. Fx is e to the power mx to the power 2. Now we know that indices rule says a to the power b to the power n, a to the power n to the power m is a to the power nm. So why don't we apply that? And then all of a sudden this become very simple, right? So they just given this like this to scare you, right? So that is e to the power 2mx, where m is a constant, right? M is a constant because x is the derivative, right? So now you can see it's a very simple question, right? Now let's so we want to find the derivative of nth derivative. Let's first find the first derivative. Forget about the nth derivative, right? So let's find the f dash x, f1x. So that is, now you can see there's a constant, right? You can think of it as a x. Then of course if you consider constant, you can say constant times e to the power this one, right? 2m e to the power 2mx. So I'm applying the chain rule, or I'm just using the special case. Now let's do the f2x. Now this is a constant, I can take it out. Then I have to differentiate this. So again the same thing as this one, 2m e to the power 2mx. Or I can write it as 2m squared e to the power 2mx. Right, so let's look at the f3x. So that means I have to differentiate this. This is just a constant, f3x. So I can take this constant out, 2m squared. Now I have to differentiate this. That means 2m times e to the power 2mx. 2m times e to the power 2mx. So that you can see that 2m cube e to the power 2mx. Now you can see the pattern. When it is 1, 2m times e to the power 2mx. When it is second derivative, 2m squared times e to the power 2mx. When it is third derivative, 2m cube. Now you can straight away write what is f4x, right? Now you must be able to see the pattern. So the f4x is going to be 2m to the power 4 e to the power 2mx. Now you can see that if that is the case, your fnx is going to be 2m to the power n. This is not going to be changed, e to the power 2mx. So you can see whether you can see patterns. So intelligent people can see the patterns, right? Right. So the answer is something like this, and see whether there are variations from this answer also. 2m to the power n e to the power 2mx. 2m to the power n e to the power 2mx. Now this is the answer because 2 to the power m, 2m to the power n means 2 to the power n m to the power n. So this is an answer, right? This is an answer. So let's mark the answers. This is an answer. Let's again look at the answer. 2m to the power n e to the power 2mx. Yes. So this is not an answer. This is answer, right? So this is same as this one. 2m to the power n, 2m to the power n, and of course e to the power mx, e to the power 2mx, I can write it as fx because e to the power 2mx is what? Fx. So therefore b and d are answers, others are not answers. Okay, b and d are answers. B and D are answers, right? So again, so just check whether you have that courage. Can you see the patterns? Do you have that patience, right? So you don't get fear. You are not fear of complexities, right? That is what they are checking. Right, so I'm just taking the easier one first. Right, so this is another very easy one. Right, very easy one. This is, I think, the easiest one in your paper. So they ask you to find the second derivative of fx equals sine 2x plus cos 3x. Right, so they ask you to find the second derivative of sine 2x plus cos 3x. Right, so I will do it here itself because it's a very simple one. So fx is sine 2x plus cos 3x. Now let's differentiate first ones, f1 x or f dash x. Now this is summation. I can differentiate this plus differentiate this. That is summation rule. And of course, when we have constant, you can take it out or you can apply the chain rule. So let's think of it as a constant. That means what? Sin x derivative is cos x 2 times cos 2x plus derivative of cos x is minus sin x, therefore minus 3 times sine 3x. I just applied the chain rule straight away. Now I am now making it shorter, right? So that is f dash x, but you have to find this second derivative. Therefore let's do it again. F double dash x. Now summation rule or subtraction rules. Derivative of this minus derivative of this. I will take this constant out. Now this is again, I can do the chain rule, or I can just use the constant multiplication rule. So cos derivative of cos is minus sine minus, so I have to multiply it by this constant sine 2x, here minus 3 sine 3x is cos 3x. So answer is minus 4 sine 2x minus 9 cos 3x. So that is my answer. So see whether we have the answer. Minus 4 sine 2x minus 9 cos 3x. This is an answer. And see whether there are any other compatible answers. So D is an answer, right? So you have to check with the others are also compatible, right? So D is an answer. Yes, answer is D. Right, so let's do this one also, 18th one. So they ask you to find the 29th derivative. Now if you are really scared person, you are not going to do this, right? If you get scared by big things. So actually what they want to do is filter out those people who are scared of things, right? Because IT is not your field. IT is not your field. So you may have some other fields, right, that you are really good at. Let's take this. Right, so they ask you to find the 29th derivative of fx, right? 29th derivative. So let's take fx again. We are not going to do it 29 times. We are going to go do it until you find a pattern. Right? Until you find a pattern, you have to continue. Maybe once, twice, thrice, 4 times, 5 times, maybe just 6 times. So by the time you must see the pattern. Okay. So let's see. So in my case, so let's take the pen. Fx is cos x minus sin x. So I'm going to do the first derivative, and I'm subtracting rule, derivative of this minus derivative of this. So we know that derivative of cos x is minus sin x, minus derivative of sin x is cos x. So we are done with that. Still I don't see any pattern because this is different from this one. Therefore I have to look at the second derivative also. f2x is now minus sin x is derivative of sin x is cos x minus cos x minus derivative of cos x is what? Minus sin x. Minus into minus is plus sin x. Now still this is different from this one. This is different from all the other two. Still there are no pattern. So therefore let's do it again. I'm differentiating again. f3x, right, minus times derivative of cos x is what? minus sine x. Minus into minus is plus, that is sine x. Right? Of course, derivative of sine x is cos x. Still there is no pattern. This is different from this one. This is different from all these. This is different from all these. Still no pattern. Right? So you can see these four are four different things. That means still no pattern. Right? Let's move on to the next one. f4x. So derivative of sine x is cos x. Derivative of cos x is minus sine x. So now we have the, now we can see this is same as this one. This one, right? Cos x minus sine x. That means my f5x is going to be what? This one. My f5 is going to be f1 again. So now you can see the pattern. 1, 2, 3, 4. My 5 is same as 1. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So which one they want? 27. 17, 18, 19, 20, 21, 22, 23, 24, 24, 25, 26, 27. So what they need is 27. Just there. No, 29. 29. 28. 29 is going to be same as what? Your first one. Your first one. So that means your answer is going to be minus sine x minus cos x. Right? Minus sine, because it's going to be same as your first one. Because now we can see the pattern. You can see the pattern. It's going to be minus sine x minus cos x. Right? Minus sine x minus cos x. That must be the answer. So minus sine x minus cos x is what? B is the answer. Right? B is the answer. The answer is B. Right? So I have given you very clearly each and every step. Right? Because I know this is something challenging if you have not done maths in your A level. Right? So for those who have done A level maths, this is not a challenging paper actually. Right? Here the A level paper is far more challenging than this one. Right? So that is why I have given you all the steps, right, to help you. Okay. So now let's take some serious questions. I took the easier one. Right. So when I say serious, sometimes just you have to have the courage. Sometimes of course you need to know few techniques, because in any field there are some well-known questions, right? Well-known questions, typical questions. Of course that is why you need some experience, right, when it comes to math. Of course you have to understand the concepts, then you must have exposure to problem solving. Then you encounter those popular questions, then all of a sudden in the exam also you find that okay, that popular question I have seen, right? That is why when it comes to maths, when it comes to some other subject, you have to keep memorizing, right? Some other subject, botany or zoology or chemistry, your task is keep memorizing. When it comes to maths, your task is understand the concept, do some questions. It is not memorizing. Get familiar with some possible scenarios that you may encounter, because in maths world, mathematicians, maths people, they have some interesting scenarios. So face those scenarios, get familiar, because examiner is going to check whether you have meet those scenarios. Okay, so that is why you need little bit of exposure, right? Not memorizing, little bit of exposure, something like you meet with other people and get to know how they behave. Okay, right. So now let's do some little bit serious things, right? So this is of course a serious question, right? Of course a serious question. 2019 8th question. You can see 2019 they have the highest number of MCQs and also second paper question in derivatives, right? So it says, so let's copy it. Oh, I can do it here itself because otherwise it will take a lot of time. So it says y equal 10 to the power x and x increases at the rate of 0.01 meters per second. Actually, to do this, you must be really good at understanding the concept of derivative. Okay, and of course it will be challenging question. Okay, it will be challenging questions because they might repeat this kind of questions again, right? So it says y equal, so let's do it here itself. So they say y equal 10 to the power x, and it's something like a to the power x, and we know how to differentiate a to the power x1, right? And they say x increases at rate of 0.0 meters per second, right? So they are not directly saying, they are talking about something related to time or something, right? Something related to time, because they are not saying whether whether x is a time or whatever. So this is very tricky question, actually very difficult question in a way, conceptual question. The way they represent the question is also very difficult, abstract. So actually this is very abstract question. If you are really good at abstract thinking only, you can do this. Actually, if you can't do this at this level, don't get upset also. This is very abstract questions. Once you get a lot of exposure to the calculus only, you can think of the solution for these kind of questions very fast. Okay, anyway, so let's do that. So that will increase your capacity again. It's something like you go to the gym, right? You go to the gym, you keep raising weights, right? So when you keep increasing the weight, your capacity get increased, right? So you no point go there and just keep lifting 10 kilo or whatever, right? So you want to increase it, right? 10 kilo, 20 kilo. So it's similar. So this is one of the sort of a higher weight thing you are going to practice now. Okay. So our question is y equal 10 to the power x, right? And it says x increases at the rate of 0.01 meters per second. So since it is talking about something like seconds, you have to guess that they are talking of some other variable now, right? Some other variable, because it says rate of change of x. Rate of change of x. Now usually when we have y and x graph, so that is, let's really check whether you have understood the concept. When we have y and x graph, right? This is y, this is x. So if I have something like this, so what is mean by rate of change of x? So this is rate of change of y. If you take this m, to change this m, or dy by dx, right, is rate of change of y with respect to x, right? Rate of change of y with respect to x. If this is time and this is displacement, rate of change of displacement with respect to time, right? It is all about rate of change of y with respect to x, right? Rate of change of y with respect to x. But what they are talking is rate of change of x, right? You can see x increases at the rate of this, right? Now we can see it is not rate of change of y or rate of change of displacement with respect to time. It's something like, if it is time, rate of change of time, or rate of change of x, right? Rate of change of x, they are talking about rate of change of this one. But usually what we discuss is rate of change of this one with respect to this. But here rate of change of this one with respect to time. Rate of change of x with respect to time. So therefore what they really talk is something like this, dx by dt. So they say that value is 0.01, right? So that is what they are talking. So this is very abstract question, right? So they are talking about something like, because it says x increases, x not y, right? So usually rate of change of y we are interested, rate of change of d by dx fx, but they are saying this x is increasing at the rate of change of 0.01, that means dx by dt. This is very interesting question, right? If you can think this kind of abstract things, you are really super, right? Meters per second, and they say the rate of change of y. Now they are talking about the rate of change of y. So that means what? Dy by dx. So they are saying dy by dx y when x equal 2 is, you have to find, right? You have to find what? You have to find what? Find dy by dx, right? So you have to say the rate of change of y. So that one you have to find where when x equal to, that is what they are asking you to find, right? So they have given you the dx by dt, and they want you to find dy by dx, right, at x equal to, right? Now you know that dy by dx you can find because you know how to differentiate this with respect to x. That is d, if y equal 10 to the power x that they have given, we know that d by dx, this is remember that log a to the power x is a to the power x ln a, right? So that is 10 to the power x is 10 to the power x ln 10. So that is dy by dx, right? So now we have the dy by dx, right? So let's write it here. Now we have dy by dx, which is 10 to the power x ln 10, and of course we have the dx by dt. I will just delete this. So this is one of the most abstract question, just to check whether you are sort of that mindset, and of course we know that dx by dt is, that is given, dx by dt 0.01, right? Then we can apply the chain rule. Remember the chain rule, I didn't show you the rule itself last time, so now we are going to apply the chain rule in a different way. So let's look at the chain rule again. Now we are going to see a different use of chain rule. Right, so this chain rule, we are going to look at it in a different way. So this same chain rule, I can write it like this. So this one I can write it like this. I'm very sorry that I have not mentioned it in your note. So I have mentioned only this way. Actually, I should have mentioned it like that also. That is, this can be written as dy by dx equal dy by something like u or t or whatever into dt by dx. It's something like this get cancelled out, but the reality is this is not really cancel out. This is another way of writing this rule, right? So dy by dx you can write it as dy by dt into dt by dx. So dy by du into du by dx. So we are going to use this. This is the other way of writing the chain rule, right? So we can use this to find out this dy by dx at this point. Okay. So remember that you have this chain rule can be written in this form as well. Okay. So anyway, we are going to use this in integration also. That is dy by dx is, if you have another parameter variable, the differentiation of y with respect to that into differentiation of that with respect to x. So we multiply, you get dy by dx. Again, the proof is not given. This is same as your chain rule. Okay. Right. Now we are going to use that. Right. We are going to use that. This is actually this is the most difficult question you have, conceptual wise. Right, now I have this dy by dx. Now I'm going to say, now I'm going to use that dy. So what I need is rate of change of y, right? So what I need is dy by dx. Now I'm using the note itself because I want to do it speed up, right? So we know that dy by dt I can write it like as dy by dx into dx by dt, and also we know that dy by dx is 10x ln 10, and dx by dt is 0.01, right? 0.01. What dy by dx is of course 10x ln 10, but what they need is at x equal 2. Therefore, for that x I can substitute 2. Then all of a sudden it becomes 10 to the power 2 ln 10 into 0.01, right? ln 10 into 0.01, right? Because they are asking about when x equal to 2, therefore x can be 2. Then dy by dt is 10 to the power 2 ln 10 into 0.01. So the answer is ln 10, right? The answer is ln 10. What they need is the rate of change of y. Rate of change of y, actually they have not mentioned it properly. They should have asked what is the rate of change of y with respect to t when x equal to, right? So that is something wrong with the something incomplete in your question also. What they have asked is the rate of change of y with respect to t when x equal to. So the answer is ln 10, right? The answer is ln 10. The answer is A, right? The answer is A. So make sure that you have that. Actually something wrong with the question also. They should have asked it, right? The rate of change of y with respect to t when x equal to. So that is dy by dt. So dy by dt is dy by dx into dx by dt. Dy by dx we can find, and of course they are asking about x equal to, therefore I can just substitute there. Dx by dt they have given. So that is, they say x increases at the rate of blah 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 with respect to t. So dx by dt they have given. So dy by dx I can find. I can find the dy by dx at x equal to. That means I find the dy by dt at x equal to. So this is dy by dt x equal to ln 10. ln 10. The answer is C. So somewhat difficult questions, but this can be done. So this is when it comes to applications, we heavily use this kind of chain rule, right? Dy by dx is dy by dt into dt by dx. So dy by dx is dy by du into du by dx, right? Right. So again go through that. If you have any questions, you can raise that maybe in the next class or in the WhatsApp group. Okay. Right. So that is somewhat abstract question, and also the question is not properly 100% properly worded. They should have asked it that the rate of change of y with respect to t when x equal to 0, because you can see there is a x, there is a y, there is a time, right? So there are three things they are talking about, right? So that is one of the question in 2019 paper. Right, now let's look at this one. Right, again somewhat abstract question, right? So check whether you actually, this is you have to know the shape of the graph e to the power x in order to do this, right? In order to do this, this is a somewhat complex question. Unless you have the picture of e to the power x graph, ln x graph, right? You can't do this, right? Right. So which of the following is are correct about the function fx equal x e to the power minus x, where x is a real number, right? So they have given you three answers. They ask you which one is correct, which one is wrong. So if they are talking about maximums and minimums, etc., the critical points, first thing you have to do is find the derivative, or maybe find the second derivative as well, depending on the situation. So let's first find the first derivative. So I'm not doing this. I'm just referring to your note because I want to do it in a less time. So when fx is x to the power x e to the power minus x, your f dash x is, now it's a multiplication. You have to use the multiplication rule. First one into the derivative of the second one plus second one into the derivative of first one. So you know that e to the power minus x derivative is minus e to the power minus x, right? Therefore minus x e to the power x. This is the derivative of x is 1, that is e to the power minus x. I can just take e to the power minus x out, then e to the power minus x times 1 minus x. So always factorize, then only you can see where this is going to be 0. Where this is going to be 0. Now you can see this is going to be 0 when x equal 1. Right? When x equal 1, because when x equal 1, this is going to be 0. And there's one more possibility. If you are really know e to the power minus x graph, when x is plus infinity also, this is going to be 0. Actually, I don't think they have expected you to know that, but at least they expect you to see whether you see that. Now you can see when x is 1, this is going to be 0. Now they are talking about maximums and minimums. Therefore, at x equal 1, it can be maximum, it can be minimum, or it can be a point of inflection. Now you want to make sure whether it's a maximum or minimum, right? Maximum or minimum. So because they specifically say maximum, now what we are going to do is add something little bit less than 1, because at x equal 1 is a critical point. Less than 1 and see whether it's positive or negative. If x is less than, little bit less than 1, this is going to be positive value. Right? This is going to be positive value, right? And also because you are subtracting something little less than 1, this is going to be positive value. This is also positive value. Positive into positive is positive. Then if x is little bit bigger than that, so that is 1.1, 1 minus 1.1 is negative value. Negative value into positive value is negative value. Now you can see it's at x equal 1, it is going to be what? Positive, 0, negative. Right? So remember, positive, 0, negative means what? Right? Positive, 0, negative. Right? Now you can see positive, 0, negative. Right? Positive, 0, negative. Right? Positive, 0, negative. Positive, 0, negative means something like this. Now you can see positive, small angle, 0, a big angle. So that means what? Maximum. So that means at x equal 1 we are going to have maximum. Right? So that must be the answer. Right? So once you get familiar, these are not difficult questions, right? But you have to learn those concepts. Now fx has a maximum at x equal 1, so that is answer, right? So it is not always greater than 0, right? Because when x is negative value, you can see you are going to have fx as negative value. So that is, for that you have to understand the graph, right? So that, right, because when x is negative value, this is positive value, therefore you are going to get negative value, therefore this is not answer, right? It says there's a minimum at x equals 0. No, at x equals 0, this is not getting 0, right? At x, if there is a maximum or minimum or whatever, at x equals 0, we must get this 0. Now, but you can see that at x equals 0, what happens? At x equals 0, just substitute here, e to the power minus 0, 1 minus 0. So 1 minus 0 is 1. Any constant to the power 0 is 1. 1 to the power 1 is 1. So at x equals 0, this is not 0. If this is not 0, that means it is not going to be at x equals 0, we are not going to see a maximum or minimum or point of inflection. Therefore, that is wrong. That is wrong. That is wrong. So therefore, this is wrong. This is wrong because when x is negative, the value is going to be negative, and this is correct. So answer is A only, E. Right? E. Right, you can see. So I just gave you additional information. So how the e to the power x graph looks, right? Then how the x e to the power x graph looks. If you just look at, since you have to multiply it by x. Now remember, x e to the power ex means what? You have to multiply this value by x value. When you multiply 2 by 2, what will happen? 4. Again positive value. But here positive value you are multiplying by negative value, because x is a negative. Now ex is positive, x is negative. Now therefore here all of a sudden your result is going to be negative, right? Negative. So that is how it goes like that. It goes like that because here you are multiplying the ex by x, because x is negative, ex is positive, you are going to get negative value. So you don't have to go into this detail, but those who have done maths, they can interpret like this and sketch the graph also. So that is why you are actually learning differentiation and this kind of subject. You can sketch the graph. Of course, we are not expecting you to do this kind of things. This is some additional things I just gave you just to see whether you can understand those things as well. Okay, right? So that is why you learn relations and functions. So you don't have to go into this detail. You can simply, by doing this, you can find the answer. Okay, so these are just additional things for those who want to think a little bit beyond that. Okay, right? Then they have, this is limit question. So this is the only limit question I found in the last 4 years. Of course, you get limit questions in the sequence and series. Therefore, they are not checking much of limit questions in your calculus because they give it in the sequence and series. Okay, so that we have done. So this is a question. So let's take that. So let's take that. So you can see that if I just apply infinite, because that is the first thing I want to do, right? Just apply the value and see whether you get a value, then you are done. So let's see if you apply, what will happen. when n is infinity, 2 times infinity is infinity, infinity plus 1 is infinity, square root of infinity is infinity, minus infinity plus 1 is infinity, its square root is also infinity, infinity minus infinity, divided by square root of infinity is infinity. Now what is the issue? Infinity minus infinity is not determinant. So this is not determinant. So you can't find what is infinity minus infinity. Remember, that is one of the indeterminate form. Infinity divided by infinity, 0 divided by 0, infinity into 0, and infinity minus infinity. Right? So therefore, I can't just apply infinity and find this. Right? Now I am in trouble. Right? Now I am in trouble. Now what are the other things you have to do when you are in that kind of trouble? You can see factorize and see. Right? Factorize and see whether you can do it. Right? And of course, you can multiply it by the conjugate and see whether what you can do it. But remember, this is an infinity scenario. Infinity scenario, most of the time what we have to do is, actually you can't factorize this. No point multiplied by conjugate also. Then you are going to have this kind of expression in denominator. So what we have to do is divide by the highest power of n, because this is n rather than x, they have given it as n. So what is the highest power of n? You just subtract both denominator and numerator by that. That is the technique, the 3, right? Technique 3. So you have to divide by the highest power of n. But remember, when you have a square root, what you have to divide is the square of that, because when you, the highest power is what? N. Here also n, here also n, here also n. But when you have, it is, they are in the square root. Therefore what you have to do is, you have to divide by the square root of, or the n squared. Then when it goes to the square root, it becomes n, right? It becomes n. So everything is explained here. So this results in not determinant situation. So what we are going to do is, we are going to divide this by square root of n, because highest power is now n half, right? We are going to do the same thing for this one also, right? So you can see, numerator divided by square root of n, determine other one also we are going to divide it by square root of n. Then dividing square root of n means we have to divide this as well as this, right? So this is this one, this is 1, and here it becomes 1, right? So now I can take the square root out. So 2n plus 1 divided by n minus n plus 1 divided by n. Here of course cancel out 1. Now I can see that 2 n to n get cancelled. 2 plus 1 over n minus 1 plus 1 over n divided by 1, right? Now I can apply the infinity rule, because something over infinity is 0, this becomes 0, this becomes 0, then root 2 minus root 1, right? Root 2 minus root 1 divided by 1. So of course 1 divided by 1 means nothing. The answer is root 2 minus 1. Root 2 minus 1. So this is an answer, right? Because it's a multiple answer question. Sometimes what they do is, they just get some other answers also. They just have multiplied by root 2 plus 1 to get another answer. Therefore this is an answer, and this is an answer, right? So this is an answer, this is an answer. So this is another well-known question in calculus, right? So you can see there are two answers, these two answers. Okay, so if you have something like this, make sure you divide by that root value, right? Then all of a sudden you are going to get something like this determinant form. Okay, right? So it's little bit difficult question, but this is something if you ask A-level math student, they have seen this question. This is a well-known question. So that is why we ask you to go through the past papers. If you go through about 10 years of past papers, you will see this kind of question again, because this is well-known question, right? When you first look at the question, you will say, okay, another type of question. No, there are no hundreds of thousands of that type of question. There are about 4 or 5 type of questions, right? When you go through about 10 years of past paper, you cover all the possibilities, right? All the possibilities. And then when you take your question paper, you will see that, okay, I have seen this question, I have seen this kind of question, right? So this is another type of question. If it is something like roots are there, you have to divide by the root. But this is same as your power rule, right? Same as your power rule, because highest power is now n to the power half, or the square root. Because highest power is square root, we just divided by the square root, right? Same rule, but rather than x squared, x cubed, now they have given it as x half. Okay, so again go through it, right? So you find, okay, we did this question, right? So this is again very interesting question, right? So but it will take a little bit of time, therefore I am not going to do this. I keep it for you. I will do similar question, which I found I did this question. I will do a similar question to this one, so I will just keep this for you to think, right? It's a vector question, but you need little bit of uh, rate of change concept, right? Actually not derivative, you just need the rate of change concept, right? So we did this one, second paper question, right? So this one I keep it for you. This is really simple question. You have to apply the chain rule. Remember, you have to take this as x and they half this one into minus half, then multiplied by the derivative of this, right? You have to do that to find this one, then you have to differentiate again to get this one, then just calculate this one and keep simplifying, ultimately you will get 2, right? So this is just this is not derivative, this is just you have to do some simplification, right? So that is where you learn your indices, right? Algebraic fractions, right? Indices. So don't think that this is difficult. Just everything we have done, apply the chain rule, do it, differentiate twice, right? Then just simplify this and see what is the real answer. You will ultimately get something like 2, and you will get a lot of satisfaction once you get into that. You know that, okay, I did this very quietly, right? Systematically, without making any mistake at any of the point, right? So I just keep it for you, right? If you can't figure it out, let me know. I will do it in next class, okay? It is not a difficult question. It is just to see, check whether can you handle complexity. Can you handle complexity? Do you have that courage to keep working on something, right? So remember, there are people who keep trying. They all of a sudden they break out and they feel like, okay, I can't handle this pressure. But it's something like, can you hold on pressure until you get into the final answer, right? So that is important. When you are doing a final project, is also like that. When you are doing a final project, it's a complex thing, right? So some people, after some times, they can't handle that pressure. They just stop doing the they just stop doing the project. Why? They are not used to that kind of pressure, handling that kind of pressure, complexity. So yes, that is why we are learning maths, right? So once you learn this, doing these kind of questions, right, you develop that talent, or you do develop that skill to handle complexity, right? So not fear of complexity, okay? So do that, right? So do that. If you can't figure it out, at least one of those steps, I will explain in the next class, okay? Right, so we did this one, right? So now we have another question, again related to the maximum minimum. So let's do this one. So that is not difficult question. Actually, this is not difficult question if you understand the concept, okay? So let's copy this. So they are asking whether what is the maximum value, right? What is the maximum value? So when they are asking maximum minimum, you know that of course they are asking about derivatives where dfx dy by dx is 0. Right. So they have given you the fx value. They have given you the fx value. This is not difficult question. So they have given you the fx value. Fx equals 4 minus x minus kx square, and they ask what is the maximum value, right? Maximum value. If they are talking about maximum minimum deflections, you have to find the derivative. So here constant x, derivative of x is 1 minus k times x square, derivative is 2x, that is 2kx minus 1, right? Now if it is a maximum or minimum point, obviously at that point this must be 0, because in critical points this becomes 0. Now we want to find that critical point, right? So let's say f dash x equals 0, because if it is a maximum, this has to be 0. So let's make it 0. 2kx minus 1 is going to be 0, right? So what is that point? Only place where this is 0 is what? When 2kx equal 1, that means when x equal 1 over 2k. So that means when x equal 1 over 2k, we are going to have interesting point or critical point. We never know whether it's a maximum or minimum or whatever, but we know that at x equal 1 over 2k, this is going to be 0, right? You just apply x equal 1 over 2k, 2k get cancelled out, 1 minus 1 is 0. Yes, at x equal 1 over 2k, we are going to have interesting point. So what they are asking is, what is that value? Of course, you can check whether it's a maximum or minimum also, but they straight away say it's a maximum, therefore you don't have to check. So first let's see what is that value. But what they are asking is maximum value, not they are not asking when we are going to have the maximum. What they are asking is what is the maximum value, something like this, right? So of course they are going to have maximum something like this. They are not asking whether when are we going to have maximum. That is, of course, we have found that is what at x equal 1 over 2k, but they are not asking what is where do we have the maximum. What they are asking is what is this maximum value, right? So that is why they have given you the fx. Now we know where do we have the maximum value, or something interesting value is there at 1 over 2k. Let's assume it is maximum value. Now what the question asks is not this one, what they ask is this one, right? So for that, what we have to do, we have to substitute this value to the this function is given. So the maximum value is f 1 over 2k, because that is where you have that critical point. So that you have to substitute here now. 4 plus 1 over 2k minus k times x squared. X squared means 1 over 4k square. 4k square. 1 of the k get cancelled out. That is 4 plus 1 over 2k minus 1 over 4k, right? So let's take the common denominator. Let's make it 4k. In that case this will be 2. So that means 4, 2 minus 1 is 1, 4 plus 1 over 4k. So that is your maximum value. So this maximum value is 4 plus 1 over 4k. We don't know whether maximum or minimum, but we found that value. So the answer is 4 plus 1 over 4k, right? So we assume that that is a maximum value, right? So let's move on. So that is not part of your question, so they just say it's a maximum, okay? So I have given that also. You can see if it is 1 over 2k, little bit lesser, this is positive. If it is little bit bigger, this is negative. So that is additional thing I just did, right? Anyway, they have mentioned that it is a positive maximum. Just I double check whether it's a maximum. This is not needed, right? So just you have to find where it is 0, then substitute it in your function and find the, that value, right? Find that value, right? So this one we did. So this one also I am just giving it for you, right? This is not difficult question. So just you have to apply the multiplication rule, right? So then you can do it. Little bit of simplification again you have to do, right? Right. So this is the other vector question that I am going to do. I am just keeping the other one for you that we just keep, right? So I am going to do this one for you, right? So then you should be able to do the other one. Of course, the other one is somewhat difficult question. You have to think about the velocity. You have to think about the displacement. So many things. So I will do that maybe later session. But I just want to do this one with you because this one is the easier one. Once you do that, make sure you revisit the previous question and think about it. Don't look at the answers, right? Don't look at the answers. Try to do it by yourself, okay? Right. So let's look at this one. This is not difficult question. Again, this is another type of question you get. Another type of question that you have to get familiar. Okay. So let's take this. So now they are combining vectors and differentiations together. Right. So let's see. The shortest distance between fixed position I plus j and variable position I minus 2tj plus k, where t is time, is equal to. Now this is two vectors, right? These positional vectors, right? So remember ijk, right? Now you have to remember vectors, right? So you can't say that when I am studying, you can't say that when I am studying vectors I forget matrices, when I am studying sequence and series I forget vectors and stuff like that. When I am studying differentiation I forget sequence and series. No, that means you are not studying, you are just trying to memorize it, right? So you can't actually, when you study another thing, the previous concept become even more cemented, right? More strong, more solid, if you really understand. Okay. Right, so let's look at this. Right, so this is all about vectors. So if you have forgotten the vectors, just refresh it. So it's all about ijk, right? Unit vectors, ijk, position vectors. So with respect to, they have given you 2 points. Right, so the shortest distance between fixed position I plus j. So this one is what? This vector is I plus j. Right? So this, let's call it a this vector, position vector. That means this vector, right? I'm not drawing the vector. I'm just writing this is I minus 2tj plus k. Right? So using the ijk notation. Now let's call it b. Now what they ask is, what is the minimum distance between a and b? Because this b can be vary, because you can see there's a t, right? So depending on the value of t, it can move here and there, right? It can move. So this b can be something like this. We never know, something like this, right? Because of the t, right? Because of the t, because t can be 0, t can be 1. You can see all of a sudden this j is varying. I and k are the same, but j is varying. So it cannot be, I don't think it's a curve, but it's something like a straight line or something, right? So now you can see this distance is, now this distance is different from this distance. This distance is different from this distance. What they ask is, where do we have this shortest distance? So maybe something like this is my shortest distance. They ask, what is this distance, right? So this is general distance, right? So first let's see. We know that if you have x1, y1, z1 point and x2, y2, z2 point, which is your a and b, we know that if it is x1i, y1j, z1k and x2i, y2j, z2k, we know that the AB distance is x1 squared plus, right, x2 squared plus y1 squared plus y2 squared, sorry, x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So you have to take the difference and square it and take the square root. So that is how you get the AB distance. So that you have learned in your vectors, right? So that is, this distance is x1 minus x2 squared plus x2 minus y2, sorry, x1 y1 minus y2 squared plus z1 minus z2 square and its square root. So let's apply that. Right? So I'm going back to the note because I want to do it quickly, right? So that value is 1 minus, so this is 1, so this is I minus, I plus the, I write it as I plus j plus 0 k. This is I plus minus 2tj plus 1k, so that I have the k component as 0 here. This is 1 minus 1 squared plus 1 minus 2t, that is 1 minus 2t squared plus 0 minus 1, because this is 0, this is 1 squared, right? So what I get is, here 1 minus 1 is 0, here 1 plus 2t is 1 plus 2t squared is 1 plus 4t plus 4t squared, because it's a 1 plus 2t squared, that is 2t squared is 4t squared, 2 times 2 is 4t, and here 1 squared is 1, and of course 0 minus 1 is minus 1, minus 1 squared is 1. So what I get is 4t squared plus 4t plus 2. So that is my value, right? So but what I need is, so by giving different t values I get the value for AB, right? I get the value for AB. of course this is not AB, this is AB squared. Okay, so actually this has to be, there's a small mistake. I will update that document also. This should be AB squared. Okay, not AB, this is AB squared. Okay, and this is AB squared. AB squared. So what we get is this one. Now what we want to find is the minimum. Minimum. So if you now, if it is, that is a function ft equal 4t squared plus 4t plus 2. What we need is the minimum value. Of course we know that this is a parabolic shape, it will have something like that. What we need is, what is this minimum value, right? First we want to find where do we have the minimum value. If it is a minimum or maximum or whatever, what happens, the derivative must be 0. So let's do the differentiation. This is 8t plus 4. Now at that minimum point, this is going to be 0. So that means that minimum point we get at minus 4, right? Minus 4 divided by 8, that is minus half. We get that point at minus half, right? So we get that point at minus half. Now what they ask is not where do we get that, what is the minimum value. So therefore now you have to substitute minus half, substitute minus half in this function, right, or in this function, right? So substitute minus half here, 4 into minus half squared plus 4 into minus half plus 2, and that is the answer that you are going to get. Right? So what you get is, actually we are checking whether it's a minimum or maximum, that is not needed, right? So that is additional thing I am doing. So just to substitute, what you get is 1. Right? So that means the minimum distance that those points are going to have is 1. So answer is A. But because they are asking about the minimum point. Okay. So yes, depending on the t, it's going to vary. Right? Depending on the value of t, it's going to vary. Right? Maybe straight line or whatever. I think that is a parabolic or something. Right? So what you get, you are somewhere here. You don't. So what you get is, this parabolic shape is for this one. And what you get as the minimum point is something like this. Okay. So that is where you get the minimum point, minimum distance. Okay. So what we got is a parabolic shape. You differentiate and see where do we have the 0. That is where you get the minimum value, and then we substitute here, because what we need is not where we get the minimum, what is the minimum. Therefore we just substitute the value in the function itself. Okay, so that is not a difficult question, right? So once you understand the concepts, and you have to now mix both calculus and vectors together. Actually in second paper they really like to mix those two together, then only we can see whether you have really understood the vectors, you have really good understood the calculus. Because when you mix things, that is where your thinking power is going to be really tested. Okay, right? So that is a good question, challenging question, right? That's another type of question you will see. So I am always checking whether it's a maximum or minimum. Actually in the exam you don't have to do that, right? So I am just double checking, right? Give you a little bit more insight. Right, so we did this. Right, so this one I am just keeping it for you, because it's you have to do the, again you have to do the derivative and see where are you going to get the zeros. Actually again you have to remember that when it comes to sin x and cos x relations, right, function, it has infinite ways where you get 0. So that is why it says infinite many solutions. So just they check whether you are aware that sin x is something like this, cos x is something like this, tan x is something like this, right, something like this. So they are just checking whether are you aware of these functions. Then you know that of course I am going to say get infinite many solutions, right? So that is why I told you that you have to aware of the straight line, parabolic shape, then the shape of the sin x, cos x, tan x, etc. also, right? So those are the prerequisites I mentioned, right? So you must know that sin x is, it has infinite number of places where this gets 0, cos x also infinite number of solutions, tan x also infinite number of places where it gets cos, right? So So that background also you have to use. That background also you have to use to get this done. Okay. Right. So I will do this final question and finish. Right. So this is very interesting question, and almost every year, maybe every 2 or 3 years, they check whether you know this. Right. This concept. This is another very famous type of question in calculus. Right. Calculus or the differentiation. So they ask you to find what is the derivative of x to the power x, right? So we know, so this is a very famous question. They keep on asking this question, MCQ or second paper. So what they ask is, so this is my question. So let's take it, and you have to do it in a very specific way. If you haven't done this before, you can't do this kind of question, right? So you must have seen this kind of a question, how to solve this kind of question. Then only you can do this kind of question, right? Otherwise you can't. Obviously you may not get the point strategy, because there's a specific technique, right? So there's a specific technique to do this kind of question, and this is a very famous question also in differentiation, right? So I will explain how to do this kind of question. If you have something like x to the power x, x to the power x to the power x, now we can see the second part is that. So this is something very interesting question. We have to do, if you get this kind of question, this is how you do. So you just write it as something like y equal x to the power x, right? So you are asked to find the derivative of f, or what they ask is f dash x, then g dash x. So that is second question. Let's concentrate on first one. So you just write like this. Right? So this is the technique you have to do, then you are going to get the answer, right? Then you take the log of both sides. So if you have formula, right, you can take add same thing, multiply same thing, divide by same value, and also you can power the same power, and also you can take the log, because same thing means the logs are also the same, right? Therefore what I am going to do is, so let's just take the natural log. ln y equal ln x to the power x. So this is how you do this kind of question, right? First you take the natural log both sides, then now you can see that if there's a power, you can take it, right? Remember, log a to the power b can be written as b log a. So that is something you learn in your semester 1, right? Logs, and semester 2 also. So I am going to take that x out somewhere here. ln y equal x ln x, right? Now what I am going to do is, right, so this is how you do this kind of question. It's a technique again, right? So I am going to differentiate with respect to x. You have to write it like that. Let's differentiate with respect to, sometimes you will see this WRT in my note also. So this is a short form, with respect to x. So I am going to differentiate with respect to x. But here of course those are x terms, but here it is y terms. Now remember again, we are going to use that chain rule, that is dy by dx is dy by dt into dt by dx. So here we are going to differentiate, because this is not a x term, this is y terms. What we are going to do is, we are going to differentiate by y with respect to y, then we have to multiply it by dy by dx. So that is how you do that. This is another technique. So then ln y, so we are going to differentiate by x with respect to x, but what we are going to first do is differentiate with respect to y, that is 1 over y, because differentiation of ln y is 1 over y. Then we have to multiply it by dy by dx. So that is how you do, right? If it is something with y, and if you want to differentiate by x, first you differentiate by y and multiply it by dy by dx. So that is another technique. Actually now we are done with all the techniques that you need. That is another technique, that is the final technique that you are going to use. Okay, right? So it's a variation of this chain rule, right? Then of course this one you can do, this is just a multiplication. First one into derivative of second one, which is 1 over x, plus second one into, now you can see I am just reducing the step, derivative of x, which is 1, right? Now what they ask you to is find this dy by dx, because y is x to the power x, right? So that is dy by dx is, and now I'm multiplying by y times x into x cancel out, 1 plus ln x, right? Of course y is what? Y is x to the power x. So that means now I'm pretty much done with the answer. Y is x to the power x into 1 plus ln x. Of course, what is dy by dx? Now y is what? Y is x to the power x. So dy by dx is d by dx. Y means x to the power x. So that is what they asked us to do. Find this. So indirectly we found that x to the power x 1 plus ln x. That is your answer. So answer is what? X to the power x 1 plus ln x. So the answer is x to the power x 1 plus ln x. Right? Now the second part of the question says find the derivative of x to the power x. Right? So now if you are directly asked you to do that, first find this one, because we are going to use this as a answer. Now same thing. Now you take this x to the power x as y. Then again take natural log. Then ln y is ln x to the power x. Now you can take this x to the power x here. This is ln y equal x to the power x ln x. Now again differentiate with respect to y. This is 1 over y dy by dx. This is first one into derivative of second one plus second one into derivative of first one. Right? Of course, this is 1 over x. Right? 1 over x. X to the power x into 1 over x. This is ln x into, now we found that, right? So we found that value as x to the power x into 1 over ln. Now you have to use that. You are just substituting that, right? Again you find the dy by dx. Now in this case dy by dx is what? Y is x to the power x. Now you get the answer as this. So that is your final answer, right? So but here remember, when you are doing second part, this one you are using the result of this one. So if your question is only this one, first find this and use that answer to find this. Okay, so the concept is you write it as y, then you take the natural log of both sides, then you differentiate with respect to x, then you just find the dy by dx. That is your differentiation. Okay, so that is very popular question, right? If you don't understand it properly, again go through it, right? Again go through it. If you go to the Khan Academy, there's a very good tutorial, right? So if you go to something like Khan Academy and differentiation, because I am going it very fast. Khan Academy, they are doing it in about so many sessions, right? So many sessions. And also he is explaining it really good, right? Of course when you go to YouTube, there you can find hundreds and thousands of YouTube tutorials, and of course this is going to be one of the tutorial added to the YouTube once I upload this. This is a very quick overview. So you will see set of things, limits, right? So you can see this history, Newton, Leibniz, then derivative as a concept, right? Secant line, so that means a tangent, right? Derivative notation, derivative as a slope of a curve. They are very slowly they are giving you those things, right? Derivative and tangent line equations. So likewise it goes, right? So now you can see that x to the power x will be there somewhere. I don't know, somewhere it should be there. Finding derivatives. So I think now you can see we have to go. Let's see. So you can be sine, cos, tan, e, x, ln x. So you have to take some time, right? So this is calculus, quotient rule, right? So some optional videos they have given, right? So likewise, this x to the power x will be there. So let's do something like derivative of x to the power x to the power x. So x to the power x. You can see. Yes. So this is I think x to the power x question. So it take about 9 minutes to explain how to do that. And it is using the same concept, right? If they are not using a different concept. So let's see whether that is this question. Yes, I think composite exponential function. So you can learn from anywhere, right? So I am just facilitating you to start learning, right? So internet is your resource. Internet is your resource, not your reference book or whatever. That is old way of thinking. The new way of thinking is internet is your right. So this is exactly the video I am looking at. So it will explain it again, right? So very slowly. So I don't know why it is not playing. So let's refresh it. Maybe internet is a little bit slow because I am using for my Google Team also. Maybe that is why it is not getting played, but I hope I can. So go through especially go to the Khan Academy, and there are so many YouTube channels, right? So you can see x to the power x to the power x. Yes, now we are getting.
A bit of a classic implicit differentiation
You can
problem.
see it's a classic one,
Y,
well-known one.
that thick, y is equal to x to the x, and then to find out what the derivative of y is with respect to x. And people look at that, oh, I have x to a, I don't have just a constant exponent here, so I can't just use the power rules. How do you do it? And the trick here is really just to take the natural log of both sides of this equation. And this is going to build up to what we're going to do.
Right, you can see they are taking natural log and keep doing. So look at those things, right? Khan Academy is really good one.
So the chain rule, what's the derivative of this with?
So then you have a lot of time, right? I am just rushing through it, right? I am not a Khan Academy. I am rushing through it. You have Khan Academy. You can go to the YouTube and learn other concepts. If something is not very clear, do a Google search, do a YouTube search, right? Okay, so we are going to stop at this point. I hope you got it, right? So if you have any questions, raise those things in the WhatsApp group, and of course you can go to the older past papers if you have found any past paper questions, because we did only 4 years of past papers. If you found anything that beyond that also, any question, just post it to the WhatsApp group. I'm going to help do that question. Okay, right? So let's stop it. Thank you.